high desert in the great American Southwest. I bid you all good evening and or good morning on a Saturday morning. Or would this be Monday morning in replay? Hard to tell, huh? Anyway, good morning from the Tahitian and Hawaiian island chains in the west to the Caribbean and the U.S. Virgin Islands eastward, south into South America, north well to the pole, and of course worldwide on the internet. This is Coast to Coast AM. I'm Mark Bell. Great to be here. Tonight, Richard Hoagland and Dr. Tom Van Flandern, and we'll be discussing no less than an argument that really, of course, in some respects, it's a response to last night's show with NASA. But it is an argument no less than that which regards our origins, the origins of the human race, the origins of our Earth, the origins of everything that is. So it is a very non-trivial difference that we discuss. And we're going to do all that in a very few moments. Underway in a moment. Science Award winner, advisor at one time to NASA, and Walter Cronkite, science advisor to Walter Cronkite, Richard C. Hoagland, and Dr. Tom Van Flandern. Dr. Van Flandern is an astronomer. His PhD from Yale in 1969 in celestial mechanics. He deals now in origins of things. Things like man, meteors, asteroids, all that is. So let's see if we can bring these two gentlemen on one at a time. Richard, are you there? Yes? Is that a yes?
That's a yes.
Okay. And Dr. Van Flandern?
Yes, this is Tom.
Good.
I'm in Washington, D.C.
In Washington, D.C. How's everything in the Beltway?
Well, it's NASA territory here, of course.
All right. Last night, I'm sure you both had an opportunity to listen. We had two people from NASA here, a rather unusual opportunity to have NASA present in the personages of Don Savage and Ray Villard. And I guess I would be interested in your takes on what you heard last night, and that will take us, I suppose, many places. Who would like to begin?
Tom, go ahead. Okay. Well, it seems as though NASA has had a long history of having difficulty dealing with new paradigms. I'm thinking especially of when it was first brought to NASA's attention that there were some unusual landforms that they'd photographed on Mars back in the late 70s, and when DePietro and Molinar first brought the so-called face on Mars to the attention of the American Astronomical Society, NASA's first reaction was denial instead of interest. This is something that is a potential discovery. There is potential there for something to be artificial, to be built by intelligent beings. The evidence was very sketchy, very preliminary, but enough to be interested in following up on. But their gut reaction was to say it was a trick of light and shadow and not to research it. It was left to private astronomers and other specialists in other fields to do the researching on it. And that pattern of denial seems to right down to the present. Any number of incidents can be cited. I know that Don Savage and Ray Villard are doing their best. And they are justifiably proud of what NASA is accomplishing with the massive new instrumentation that we have, bringing in data all the time. None of the individual thousands of men and women who work for NASA necessarily agree with everything NASA as an agency says is its policy or its consensus view. Nonetheless, it is strange how the official pronouncements of NASA always seem to be denial, even where there's a lot of good evidence that one ought to be looking more closely at many of these issues, and I think we'll touch on several of them tonight.
All right, I have one question for you. Give us all a little why it's important that we understand the makeup, for example, of comets. What will comets tell us about our own origins?
Well, comets, it's a question of what are they and where did they come from? Initially, astronomers had no idea and began to formulate a number of theories. The one that Fred Whipple formulated in 1950, come down to us today as the dirty snowball model, is one idea of what comets are, but
okay,
there are others.
Doctor, what does that mean, dirty snowball? I mean, that means water, right?
Yes, that's right.
Water and ice. All right. Now, where would water and ice originally come from?
Well, according to their theory, it comes from leftovers from the huge cloud of gas and dust that formed the whole solar system billions of years ago. The outer parts, there were little bits of gas and dust left over, and they condensed into these small bodies that we call comets, and they're just among the planets and all the way out into interstellar space from there. That was one idea, and it was the best they could do at the time, but a whole lot more data has come in since then that suggests that actually comets and asteroids are pretty similar objects. They're both fresh from the sun of something that broke up, and there's a lot of good evidence that something that broke up was one or more planet-sized bodies, one of which was in the inner solar system between Mars and Jupiter, where we have tens of thousands of large rocks orbiting the sun today. Another one apparently beyond the orbit of Neptune, where we're starting to discover what may possibly be another asteroid belt, often called a comet belt.
So then, is an asteroid a comet that has simply finally disgorged itself of all the loose material or looser materials? Is that a fair comment?
Yes, that in the exploded planet hypothesis, that asteroid volatile because they haven't been baked off by the comet being close to the sun for a long time.
All right. Well, we did learn a couple of things about Comet Hale-Bopp. One of them was all the tails it had, including one made of sodium.
That's right.
Kind of a surprise for everybody. What would that tend to indicate to you?
Well, Richard is laughing because he deserves full credit for this suggestion. But if the comets have water, and we do see that in their spectra, and if comets now have sodium, which was a surprise because they're supposed to be primitive bodies left over from debris that formed the solar system in the outer parts. But the next logical thing would be chlorine. And the reason that's logical is because when sodium and chlorine are together, you have salt. And that would imply that the water in the comets was salty, and that would imply that it came from an ocean, which is salt water, as, for example, from a large planet that broke up and ejected these things into space. So
is there any way in the traditional model of sodium would be present? In other words, literally a deposit. I imagine on this comet a deposit of sodium that would be necessary to create a tail, as in a mineral deposit that you would find, say, here on Earth.
Well, it's actually a little more interesting. In the last week, since Tom and I have talked almost every day, trying to get NASA to do observations with Hubble of this incredibly interesting opportunity, which is rapidly slipping away, at least in terms of the Hubble opportunity. We've been comparing notes, and I'm spending a lot of time surfing the net. I've never really had the time, and I've taken the time to go and look at every Hale-Bopp page I can find in the world.
Yes.
And I've been particularly zeroing in on the professional observatories and the major research institutions like the Lunar and Planetary Lab at the University of Arizona, or the Pic-de-Midi page from the observatory, which is 14,000 feet up in the southern part of France, in the so-called Pyrenees Mountains between Italy and France, and many others. The European Southern Observatory, which is headed in Germany, but has telescopes down in the southern hemisphere in, I think it's South America, isn't it?
Yes, that's right, in Chile.
In Chile, along with places like Sierra Tololo and the National Astronomical Observatory of the Japanese. I mean, I was on their webpage last night while I was listening to you discuss with your NASA friends, Art, what you were discussing. And what I've been doing is compiling and synthesizing all of these little bits and pieces of electronic public snippets, flash pictures, from this place and that researcher and this observatory and that research institute to try to gather this material together on what is being painted of what we know about this incredible thing called Hale-Bopp, the real Hale-Bopp. And the more I have been putting this together, and obviously there's a reason why I'm doing this, I'm going to put expanded papers or articles on our website to follow the one that I put on last week relating to Tom's model. And what I've been looking for is evidence to either support or refute some of the major predictions of the Van Flandern cometary satellite model. And what's so incredibly interesting and really exciting and thrilling is that the more I'm looking, the more evidence already is in hand in favor of Tom's basic thesis. Comets are fragments of a former exploded planet.
All right, now let's try and get to the basis of why you and Tom are buds. Why is it that Dr. Van Flandren's model is a pleasurable thing for you to contemplate, Richard? What does it confirm about what you believe, or vice versa?
I mean, you got to understand, Tom, that I used to do astronomy and science when it was fun. It hasn't been a lot of fun over the last 15 years to try to solve the mystery of Cydonia and find myself at times in a shooting war with our friendly local neighborhood space agency for simply trying to find the truth.
I know, but what is it about the exploded planet theory, Tom's, that lends itself to validating Cydonia or anything else that you believe?
Well, that kind of comes at the end of the story. What's really exciting to start with is that if Van Flandern is right, if the asteroids and comets are not the little Bergy bits left over from the mop-up formation processes of the whole solar system, billions of remains of a planet or planets, plural, which for some reason over the 5 billion year history still bang in the night.
It is important that we know that planets can blow up.
Well, the obvious question then is, how the hell do they blow up? What makes them blow up?
Yes, very good question.
And one of the main drawbacks, one of the main arguments against Van Flandern, since he's been putting this forward in the scientific literature, has been at many conferences, people will come up and they'll say, you know, Tom, you really got a nice idea, but come on. There's no energy source. We don't know of any way to blow a planet up.
Right.
And it's been that which has been the showstopper. Well, from our work and the work in hyperdimensional physics and the evidence of a non-terrestrial presence, an ancient intelligent presence leaving fingerprints around the solar system, i.e. artifacts, we're drawing the threads together where A, we've got a bunch of guys out there before us, B, they had some incredibly sophisticated technology and knowledge of how the universe works, much more sophisticated than we currently admit to, and C, if you put it in the wrong hands, people can blow planets up.
All right, well, that was where I was going. Is a planet blowing up some sort of, do you imagine it to be a natural process, or do you imagine, Richard, that somebody blew up a planet?
In the 60s, and I'm going to do tonight what I do a lot of times. I will not answer your question directly because I have to give background. Like a lawyer, I have to lay foundation. In the 1960s, the U.S. Timing Service, the Naval Observatory where Tom worked, was looking for a better clock.
Right.
And they wound up inventing the maser and the laser. All right? And then, about 10 years later, Tom, we found in interstellar space with radio astronomy that nature had already invented the maser and the laser. Under very unique natural conditions, these incredibly precise mechanisms to generate radio waves and light waves, all ordered, all in step, coherent is the term, can be created by nature. So whatever humans or intelligence can create in the way of a technology, we usually find that at some point the universe has figured out how to do it first before we thought of it. So if, in fact, an intelligence, and it's almost like an oxymoron to think of intelligence blowing up its own planet, figured out a technology to blow up planets, then the odds are that the universe itself already has figured out how to blow up.
All right.
Either way, we need to know.
Oh, yes. Oh, I agree. All right. Stand by, Richard. Richard Hoagland and Dr. Tom Van Flandern are my guests. So I think the answer was that both in nature and unnaturally, planets can blow up. I think I just got that. We'll be right back. Back now to Richard Hoagland and Dr. Tom Van Flandern. Gentlemen? Okay. So in other words, Richard, bottom line, you believe that planets can actually blow up either en nature or with the help of somebody who knows how to do it.
Well, this is what we'd like to find out. I mean, remember, this is the cutting edge of the known and the unknown. We don't know this. Tom and I are not saying this, in fact, is what happens.
All right, Tom is an astronomer, so he's a reasonable person to ask. Tom, we've been looking at the heavens for a long time. We have seen novas, supernovas out there. Have we ever seen what we think might have been a planet blowing up?
Well, things that we call classical novas might be actually planets orbiting other stars blowing up. They tend to be invisible companions of visible stars. That's
I mean,
right.
like one night you see a spectra, and it looks like a perfectly ordinary, average, run-of-the-mill star. And the next night it's 1,000 times brighter, and then the next night it's 500 times brighter than that, et cetera, et cetera. Astronomy, because you can't see most of what's beyond the solar system, is what we would call model-driven. You make pictures in computers, ideas, put equations together, create, graphic models now you would call them, from Star Trek. But in fact, we don't see what's going on. What astronomers do, predictions, they're mathematical predictions against the light curves, the spectra, the other sensor data that comes in, and it's usually the best guess. It's incredibly imprecise, which is why you need more good data. And why not having Hubble data from Hale-Bopp is a tragedy in the making before our very eyes.
All right. Last night, I did indeed question Mr. Savage and Villard, particularly on this subject, Mr. Villard, about Hubble's ability to look at Comet Hale-Bopp, either at the closest approach or as it leaves. His comment was that we thought about it, we considered it, but to the multi-billion-dollar telescope was too great. What is wrong? Is that an incorrect assessment? Is there no risk? Some risk? How would you gentlemen characterize that reply?
Tom?
Well, we've looked at that, Richard especially. Originally, they were saying that they couldn't do it at all, and Richard pointed out that you have this opportunity during the shadow, and as was mentioned last night, they had already tried this once before with Venus. Also, it is possible, in principle, to even observe the comet while the telescope is in daylight, and put the cap back over it before the pointing angle gets too close to the sun, before the light floods and damages some of the instrumentation. They don't like to do that because it vibrates the telescope quite a bit, and there are other concerns. But there are ways to do this if the will is there, and the risk, it's always a question of risk versus reward, but the risk is fairly minimal, and the rewards would have been great indeed from our perspective. That is, a chance to compare models of really comets are, a chance to see the nucleus of the largest comet to come by in our lifetime up close, and to see whether the spiral structure originates on the nucleus or through one of the escape points for orbiting material, with the chance to use that spectroscope and see if there's chlorine in the comet or peroxine that would prove the case that the nucleus is really an asteroid and not a dirty snowball. But NASA doesn't see those things as really desirable to see, because it would cause the whole agency to change course with the investigations it's been doing and the research it's been funding. So in a way, it was sort of taking a small risk for not a reward, but something that would make their lives less pleasant.
The problem, as I see it, is we have science by committee. And remember...
Oh, they admitted that.
Well, and committees, camels are horses designed by committees. That's the standing joke. You don't get real innovation or real courage from a committee. The other joke is that you can take the IQ of a committee and divide by the number of people on the committee in terms of the average IQ, and that's the IQ of the committee itself.
Right.
I remember, I used to be with Cronkite. I was at CBS. I covered this extraordinary, unprecedented adventure called going to the moon.
Well, how does NASA's, you said, you remember many times, Richard, you have said NASA was once one kind of agency, very open, and over the years it has changed.
Well, let me give you a classic example.
Did they operate by committee in the beginning?
No, they operated by individual, courageous administrators or top-level management pushing a point, pushing a cause, pushing an idea, and basically many times saying, damn the torpedoes, full speed ahead. And I'll give you a classic example, which put something on the line far more precious than a $2 billion telescope and NASA's reputation. It put human lives on the line.
Yep.
And NASA bet on their lives, and the nation won. And the example was August of 1968. After Wally Shepard and his compatriots successfully flew in Apollo 7. I remember the absolute shock that went through the technical community, the NASA community, when NASA decided to simply switch around all of the following Apollo missions to take what they called the full-up stack, which was the Saturn V that had never been tested with human beings before, to take the command and service module, which had never been tested beyond low Earth orbit. That had been done it was going to be done in October, all right, hadn't even been flown yet. And the absence of the lunar module. They had no way to get home a la the lifeboat mode that came into the fore in Apollo 13. And the upper-level management decided, gutsy decision, George Low was the guy who did it, that they would commit Borman, Lovell, and Anders to go on Christmas Eve to the moon, Alice, to the moon, with no way, without a prayer, of getting home if one critical piece of equipment didn't work, which was the Aerojet General service module engine, the 20,000-pound thrust service module engine. It had to get them out of lunar orbit to get them back to Earth, and if that engine failed, a single-point failure, 3 men would have died on global television in lunar orbit before the horrified gaze of the entire world.
What pushed that decision?
Well, it's a very good question. And it may have been, the feeling of the Russians breathing down our back. The point is that it wasn't science. It wasn't just to know. It was for God and country and national pride, and it was human beings on the line. And if you don't think the entire agency was risking everything,
sure,
including the rest of the Apollo program, including John Kennedy's dream, including their jobs and how they looked and how the nation would have excoriated them if those astronauts had died in lunar orbit, and yet they went ahead and did it, and it was a completely unknown system. There were so many unknowns in that equation, from the rocket to the spacecraft to the hardware to the navigation, and they did it.
The only breathing that the Russians are doing down our back right now is because they're curled up to us. And we are that close to them, and yet we're doing nothing spectacular. The biggest decision we're making is whether to send another American to Mir.
Well, my point is this, and that's not the only example of NASA really having the kahunas to do something that it really should be doing. In this case, Tom worked out, I worked it out. It turns out that we were late on the block. Hal Weaver, who was their designated Hubble comet guy, had also worked it out. And I didn't know, but when Weaver went to them, they told him that they'd already tested it, you know, looking from the shadow at Venus, close to the sun. The amount of risk versus the benefit would have been minimal, and I worked out the numbers. I mean, slewing the telescope, closing that big door, it's a 10-foot door on the front, which can be closed in fraction of a second by computer command. So, I mean, the risk was minimal. The real risk, as Tom has correctly pointed out, is if they got the data, both the pictures and the other data, that proved Tom Van Flandern right, then the risk is to the entire NASA community, which has been betting for 30-plus years on the Whipple model. And if it's wrong, then all bets are off of galaxies all over the solar system that NASA has been putting together as this huge house of cards over the last 2 or 3 decades.
Are you suggesting, then, that NASA has become so bureaucratic, so tied up in its own belief system, that it is no longer an organization of science and discovery, that it will refuse to discover something new? That's quite a charge.
I'm not suggesting. I'm pointing out as a quintessential example, Europa.
Okay,
but that's
Europa.
For the next several hours.
Question to have. As you well...
Well, you can break in here at any moment. You know, I don't want to monopolize.
Well, I was just going to amplify what you were saying before we to pick up on Europa. That there is it's been an evolving situation, as Richard says, and there is a strong tendency now, through several years of tight budgets and highly strong competition for grants and funding of ETA and the NSF, but there's a strong tendency to stay with the standard paradigms. The challenging models can no longer successfully compete for funds because they can't get enough glowing reviews for something that's challenging to the mainstream to compete with the vastly oversubscribed mainstream research proposals. And when you put in a proposal to NASA, if you get one bad review, somebody trashes it. I had a proposal years ago where somebody said, given who wrote this, I'm not even going to waste my time reading it.
Really?
And there's no opportunity for at all, unlike, say, with a journal where there's peer review, at least the author can respond, but not with proposals.
In other words, they just say it doesn't make the cut. And
it doesn't make the cut, so that means the basics don't make the cut anymore. And you get all this inertia buildup. The astronomers who propose an idea like Whipple, and I don't want to slight Whipple here. He's an excellent astronomer, and he is very open-minded. But many of his followers and the dirty snowball proponents attach his name to this, and they consider challenging his model as almost a slight to the man himself, which isn't really reasonable. He's a great astronomer, and his legacy will be what it is no matter what.
All right, let's try and bring this home to the people a little bit, because a lot of people are going to sit out there and they say, who cares whether it's a solid snowball or a bunch of orbiting pieces? Why should we care? What is it, or even in the larger picture, science at all? Why should the American people care?
Well, again, the origin of comets tells us something ultimately about our own origins. If the origin of comet, and that would be astronomically recent, not in historic times, but at 3 million years ago, that's quite recently in the history of the solar system, which is billions of years old. We need to know about the circumstances that led to this. It'll change our whole picture of the history of the solar system. And 3 million years is very close to the date of the origin of the hominid species here on Earth. We can touch on that later, the whole tie-in with Mars and Cydonia and so on, but there is a possibility that natural or an artificial process, the planet blowing up or the object blowing up 3 million years ago. It may have been not just by chance, but causally connected somehow with the evolution of the hominid species here on Earth.
All right. Is there any way to, in any model, understand where it blew up was when it blew up, based on orbits of comets and so forth?
Yes, there is. A traceback that was published almost 20 years ago now. Traceback of comet orbits that shows the strongest evidence, the dynamical evidence, that comets did originate from the explosion of a body in or near Mars and Jupiter approximately 3.2 million years ago.
3.2 million years ago. And that's just the history of the universe, and certainly in the history of the solar system. Where I'm coming from is, I'm looking at a science quest, because if you get into the sciences, as I did at an early age, you really have to start out motivated by wanting to know. And then as you find that there are these fossilized bureaucrats in your way and the knowledge, you tend to get a little bit pissed off, particularly when an agency which has been formed and in the minds of most people and most hope for mankind, Reagan's shining city on a hill in the sense of being the best and the brightest and dedicated to that knowing. And you find when you open the door that it's filled with creaky bureaucrats who were much more concerned with their public image and, oh my God, if we damage the telescope than they are with finding out. It reminds me that Kirk is in a situation with the Enterprise and the crew and all that, and it comes down to a major decision, and he has a little get-together in the briefing room, and he says, risk. He said, that's what this starship is all about.
Yeah.
And that's what NASA is supposed to be about. That's what most Americans think it's supposed to be.
Out on the edge.
You had two gentlemen on your show who basically gave us a completely opposite perspective.
All right. I have a question. Tom, it's for you.
Mm-hmm.
If this planet blew up 3.2 million years ago, is that what you said? You thought?
Yes.
How frequently does Hale-Bopp come by?
Currently, the last time around was about 4,000 years ago. The period is now a little shorter. It'll be about 2,400 years to the next return.
Okay. Are there any comets out there with return times in excess of 3.2 million years?
The short answer is no. There are some with traditional scatter. You can't always determine a period accurately, so there are some raw numbers that look a little bit larger than that, but the uncertainty 3.2 million years as a possibility.
Well, for instance, Kohoutek, I believe, was a 1.5 million year period. Am I not correct on that, Tom?
I don't even remember what the formal number was, but the uncertainty included.
Exactly. In other words, when you get out past a million,
we really don't know.
The uncertainties are such that it could be 2 million. That's why you need more data. You need more observations. Now, here's the other problem here, and this is why I say a tragedy in the making. We have not had a comet like Hale-Bopp in not only our lifetime of astronomy.
Well, I've never seen anything like it.
Well, I'm talking about the nitty-gritty details. The more I'm scouring the web and finding the reports of this professional and that professional and that institute and this institute, every single posting, every single says that Hale is 1 in a million. It's bigger and brighter and has got more stuff going on. In other words, I've almost used the term comet. It's like if you wanted to see all the pieces of Tom's model assembled in one humongous, gorgeous object designed to be observed and to be learned from, you couldn't do better than Hale-Bopp.
And so, in your estimation, whatever the risk was, you thought it was fairly minimal compared to the possible rewards of taking a 5-minute look in Earth's shadow of Hale-Bopp, the risk, in your opinion. And here now we have an agency refusing to take those kind of risks. A good assessment?
That's right.
All right. Gentlemen, stand by. We'll be right back, top of the hour. This is the CBC Radio Network.
Now, here again.
Last night, it was Don Savage and Ray Villard from NASA. This night, It is Dr. Tom Van Flandern, who is an astronomer, Ph.D. from Yale in 1969, and Richard C. Hoagland. Back in a moment. All right, now back to Richard Hoagland and Dr. Tom Van Flandern. Doctor, I have a question for you. It comes from, I believe it's Joan. Art, please ask the good doctor, if light is redshifted when passing near great masses like galaxies, if this is true, could the tremendous redshifts that have been reported to be at least partly due to the mass redshifting the light rather than the speed of the object emitting the light or the expansion rate of the universe? And if true, would not the Hubble constant be much lower than reported?
Okay. Well, touches on something that I think you asked your guest last night, too. That's another area where NASA sort of has started to promote and grant funding for one theory, the Big Bang,
right,
the origin of the universe, when in fact there are about 6 competing theories that should be on the scientific table for testing.
What is your favorite?
The universe, as I see it, is the one I described in my own book, which is a universe that is infinite and non-expanding. But the reason that has to come from first principles and has to be, you have to derive it deductively. You can't just guess at these things. Infinite
and non-expanding. In other words, it did not originate with a Big Bang, but rather was, as we think of it, always there.
That's right. And your listener is asking a question about why we think the universe is expanding.
The redshift.
The redshift of light from galaxies.
It's not due to speed of the object leaving us, in effect, but rather that as the light passes, massive things are bent. That's right. That's a little bit of a confusion of another effect, which is called gravitational lensing, which is the bending of light as it passes galaxies. But the proposal that was referred to last night by your guest was an old idea that quasars, which have these very high redshifts, might actually be shot out of galaxies. That idea was discarded years ago, and current thinking is that the redshift of very high redshift objects like quasars is gravitational, meaning not the light, but light leaving this high redshift object, it may be, say, a superdense star. It would have such a strong gravity field of that gravity field, it loses energy on the way out, and that makes it redshifted. All right.
That's another explanation of the redshift. The whole point here is that astronomers all over the place have gone over completely to the assumption that the Big Bang is the only viable interpretation. There are several others on the table. There was a table recently published that showed 20 different mechanisms that would redshift light.
All right. I want to go now to something that, again, Tom, you would be the one I think first to answer, and then Richard also. It was probably the thing that generated more anger last night with the appearance of the NASA than anything else, and that is, at one time, we got data immediately when a probe went somewhere, when the men went to the moon. We got immediate information. Now, and they explained it very carefully last night, grants and funding are given to scientists, people like yourself, Tom, and they then make a proposal to NASA, also a taxpayer organization, to send a rocket somewhere, or a probe somewhere, or do something. NASA accepts or rejects it. If they accept it, a particular scientific period of time, 6 months or a year, whatever it may be, to have exclusive proprietary possession of the data collected before the American public, who paid for the whole damn thing, gets to ever... You're a guy who would do that kind of thing. Do you defend that policy, or are you offended by it?
More the latter. I've never really understood the policy. The reward, the incentive for these people to apply for the grants and to build the instruments and design the experiments is that they get a very comfortable salary from the grant and years of work in a field doing something that they... And of course, since they're the instrument designers and builders, they have already a very natural leg up on everybody else. Software to analyze the data, they know the behavior of the instrument. They basically know everything they need to know right at the outset when the data starts pouring in, and they would, in the natural course of events, be way ahead of everyone else in analyzing and understanding that data. But the 6 months proprietary period gives them an advantage which is just insurmountable, and it's a disincentive for other people to attempt to analyze the same data. And more than that, it's a policy that's become abused, I think.
Well, disincentive. They can't examine the data because they don't have access to it.
But even after 6 months, then the instrument builders are so far ahead and have exhaustively already taken most of what there is out of the data, that there's just not enough incentive for other people to come up on the curve and do all that would be needed to reanalyze that data.
All right. Well, I'm just a taxpayer, and I understand that I'm paying for that grant money. It's public money, and I'm paying for NASA with my tax dollar. And so I got a bunch of... I'll tell you, some of the faxes were so angry that I would not dare read them on the air for the language used. Now, Richard, you have thought over the years that this change in the way we do things gives people an opportunity to either cover up or mask or change data that comes back. And of course,
wait.
It does provide that opportunity. I'm not saying they're doing it.
No, Don and Ray last night misrepresented what's been going on. There has been no change. It's always been this way. It just has not been this nakedly blatant. It's like, I'm trying to think of a suitable analogy for people who aren't into space science. And the nearest I can come is the anti-monopoly, antitrust laws that were enacted earlier in this century regarding corporations and newspapers and, you know, how many TV stations you can own in one town. Rupert Murdoch is a classic example, buying up TV stations and networks and tabloids and whatever. From the beginning, NASA had a kind of a cozy relationship with its favorite scientists. And it didn't really matter who built the instruments. They made a big deal that we used to have what were called facility instruments. In other words, cameras designed by NASA,
yes,
as opposed to cameras designed by Mike Malin. And that when they were designed by NASA, it was one set of rules, and now that they're designed by individual investigators and built by grad students, which is no way of saying slave labor, the rules have changed. In fact, from the beginning, and I know about this because I was asked by Goddard to do a history of the orbiting astronomical observatory program from beginning to end back in the early to mid-'60s when it was the honest agency that we keep talking about. And even then, from the contracts I saw and from the other examples that I had to go and compare the OAO experience against, what NASA would do is it would basically put out what's called an RFP, a request for proposal. And then scientists around the country at various universities or various laboratories, government labs, or a NASA center
would write up their best shot.
Would basically give it their best shot and say, I got this neat idea, I want to measure so-and-so,
right,
and this is how I'm going to do it, and this is the results I expect, and this is how much it will cost, et cetera, et cetera. And then NASA would vet these. They would take them in, they'd review them with a committee, a peer review committee, and they would pick scientists A, B, C, and D, and they would designate those guys as the PIs, having nothing to do with Colombo, but being the principal investigator.
Right.
And then that guy would pick his team. And there'd be this close cooperation between government and industry and the science guys, and they'd create this instrument all together. and it would fly off to Mars or Venus or somewhere, and the data would come in, and this guy, even in the beginning, would get a 6 months to a year hunting license, a preserve, a fence around the game preserve, where NASA would not allow the data to go to anybody else except him until he'd had this proprietary period expire in the contract. That's always been in place from the beginning. And Tom and I have had long discussions, and I think Tom agrees with me, that this has probably been the single worst problem NASA has had ticking in its basement, like Ross Perot's crazy ant, all right? Because it's the dirty little secret that up until last night on your show in front of 15 million Americans, most people don't know exists. And it's the single thing, in my opinion, which is basically killing good science a la NASA. Because what happens is, in the days now of the internet, in the days now of modern communications, you give someone 6 months lead on everybody else to look at data, and you've given them the universe. By the time the other guys can even begin to look, if they have any incentive to look in the first place, not only are the guys who got the contract in the history books and the textbooks and in the classrooms and all over, but they are frozen in the historical record. This is what was found at. And the billions of dollars of NASA's big PR machinery is behind them. And the individual investigator who might have another take on that same data, he hasn't got a prayer of competing.
Well, last night they mentioned the Hubble Deep Field as something that was released right away, supposedly because it's important.
Because of its importance.
But, gee, I mean, any data could be important. What they really meant is because it was so public.
Right.
And the problem is that there's a lot of data that isn't so public that maybe a lot of people don't know about, and the investigators have this nominal 6-month period which turns into a year, 2 years, or forever, because there's no policing of this, nearly as I can tell. If somebody doesn't know about data that isn't being put in the public archives, the National Space Science Data Center, then basically there's no pressure put on the investigators to ever get it there.
All right, I asked them both, gave them an extreme example. I said, suppose one of your probes went out, and just before it was destroyed, you got a clear, unambiguous picture of an alien vehicle that was about to destroy your probe. Would we hear about it? And they both sort of went silent for a moment, and then said, well, probably not. There would be a procedure. It would go to the White House. It would go to a bunch of people, and, we never really got to the bottom of how long it would take for us to hear about it. But their answer was, probably not. I said, do you still operate under the assumptions of the Brookings report? Well, no, they said. And yet, at the same time, they're saying, but you wouldn't hear about something like this right away.
Well, what I thought was interesting, and I want to go back to this proprietary data thing, they made a very clear case that, well, the reason we don't have live data now, the problems of the contracts and this blanket period of exclusivity or monopoly for the pet scientists notwithstanding, is that the data is now so complex that it just takes a lot longer to analyze it and to create pictures from it, which in their minds is what anybody is really looking for, and to put it out there.
Yeah, but if in one of these projects, Richard, one of these awarded projects, grants to a scientist, a piece of data came along of the magnitude I just talked about,
right?
They admitted it would not make it to the public right away. Now, yes, some of the deep space, really interesting, look at the suns being born, did make it to us.
Oh, as long as it's politically neutral, but ETs are not politically neutral. Now, what I thought was really important is the example they gave. And earlier in the show last night, they basically gave you what we would call GIGO answer, garbage in, garbage out. They claim the reason we can't see live data, the politics and the contracts notwithstanding, is because technically it can't be done. And what I will vehemently defend is that the curves are going in the wrong direction. Back in the 60s, when I was hanging out with Cronkite and Company, we had live television from not only the moon, but from Ranger probes to the moon, from Mariner probes to Mercury, from Mariner flybys of Mars, you know, they were put on the tape recorder, and when those pictures were beamed back,
I remember that.
we had a bunch of shirt-sleeve guys, both in the press corps and in the engineering, you know, groups of NASA, hanging around monitors. I mean, I spent more sleepless nights at JPL, up until I got to know a guy named Art Bell, watching data coming in from all over the solar system live. And not one person waived the proprietary rule. Well, how would you get around this apparent paradox? How could you have the same science rules in place and yet have live data then and not have live data now? The answer comes down to NASA's cute little definition of data. Because in those contracts, the data was the high-quality, full-resolution stuff the scientists would ultimately analyze.
Right.
What they put out over TV, even before NASA Select, over the monitors at JPL and the network,
quick and dirty conversions,
was quick and dirty, reduced NTSC 525 line resolution.
Sure. I understand.
Which technically, like a lawyer, didn't qualify as data. It was public relations. Now, there's no reason there's incredible algorithms around us. You know, we've got laptops, we've got the internet. We can see pictures from anywhere on Earth and off Earth in microseconds.
So you're saying that data could easily, technically, be converted nearly immediately?
Not only could it, but it is, and they gave you out of their own mouths last night a stunningly interesting example, and I don't think they even knew how revealing it was. They talked about the NEAR mission, the Near Earth Asteroid Rendezvous mission.
Yes. Which
was launched, what was it, last year, Tom?
That's right.
And it's going to rendezvous with Eros. 242 Eros or 244? 243 Eros in 1999. And then it will sail halfway around the sun, orbiting Eros. And you and I discussed this, Art, on one of your shows one night. All right? On its way to Eros, this June, it's going to fly by another asteroid called Matilda. And Don and Ray last night divulged that, in fact, there's going to be a bunch of reporters, they hope, at JPL and other NASA centers looking at NASA TV screens live, watching pictures come in live from Matilda. This is the identical technology, CCD cameras and downlinks and X-band transmission and all that is being used on Pathfinder and is being used on Galileo and is being used on Global Surveyor. In other words, it's the state of the art. If they could admit they're going to give us live pictures of Matilda, why can't they give us live pictures of everything else? Answer, because they don't expect anybody to be waving from Matilda.
All right, gentlemen, hold on. When we come back, we are going to delve into this a little further. Since STS-48 and some of the absolutely incredible photographs that came back that people are still arguing about, and now some latter ones. I asked them about STS-80 or 82, I can't recall which it was, and they said, well, we don't know anything about that. But we got into quite a discussion about whether or not shuttle video, either inside or outside, is delayed. And so we're going to talk about that when we come back, because I think we have yet another area of disagreement. From the high desert, this is the sea.
From the Kingdom of Nye, Coast to Coast AM continues with Art Bell.
I have to say this is one of the areas where Richard and I have come to different diagnoses.
All right.
Compare the opinions of any two scientists. I think they're going to disagree in several key areas just because you judge data differently. But to me, the explanation advanced by NASA for what was going on, the light to meet the firing of thrusters and then the turning of the spacecraft, causing the reversing of direction of particles that either were in the shadow of the vehicle or outside of it. That seemed to account for what I was seeing in those pictures. Not just account for it in some stretched way, but it seemed to be a plausible explanation to me.
Well, I respect Tom's opinion, and I would say in the defense of the data that he has not had the time to look at the second generation video we got out of Houston. We finally got a much better version of that sequence shot from the shuttle in September of 1991 than has been on television, has been purveyed around the UFO community, has been actually even available on our UN tape. And Tom has not seen this much higher quality version, where there's a lot more interesting things going on, as apparent at casual inspection of the version which has been out there. But that incident notwithstanding, what he really hasn't seen is the STS-80 footage, which was shot with an outside camera in the payload bay on the Columbia mission last December.
All right. The gentleman I had on last night didn't know anything about that.
Well, not many people do, and I would take them at their word because Don is in the Office of Space Science. And remember, NASA is a bureaucracy. It's become incredibly compartmentalized. I probably almost a dozen times when Don Savage said he didn't know to some of your questions last night.
Right.
And some of those occasions I thought he didn't know, and the other occasions I thought maybe he knew, but he didn't know enough to know exactly what to say and what not to say, so discretion is the better. How many people have seen this footage? What we have done, including Tom, what we have done is now to go back to Houston. We have requested and received with credit cards, so there's a paper trail, copies of this footage from the NASA master tapes themselves. That's the first thing I wanted to do, was to verify that political NASA data. You always have to wonder, is someone in this day and age of the computer pulling a very interesting hoax?
All right, you have not yet even sent me the STS tape, so I'm good against Richard in that
Well,
tape.
let me tell you what we're doing, and then I'll back up and tell you what's in it.
All right.
So what I've had a duplicate set of this original data on high-quality broadcast version beta sent to a team of orbital dynamicists, celestial mechanics experts, kind of like Tom.
Because I was going to say, Tom is in that category.
Yep. Except Tom deals with things normally, and these guys designed the systems that took astronauts into Earth orbit with Mercury, Gemini, so they're used to the flight dynamics of things where you can change orbits. We have to do it using rockets, all right? The first blush account from one of the key engineers who's leading this team, who may in fact be listening tonight, when I sent him the earlier tape prior to are getting the ultimate version from Houston, was, my God, I don't believe what I'm seeing. Now, what I've asked this team to do, which we will put on the web. By the way, the Enterprise Mission website is www.enterprisemission.com. There's a whole range of papers up there, including links to Tom Van Flandern's site, which is metaresearch.org?
Yes.
Okay. Expositions on the Van Flandern model, a summary of some of the data we found on Hale-Bopp, a response point by point to by the gentleman last night. There's a whole bunch of stuff on our website. In the next week or two, when this paper is completed, we will put a version of it on the web with diagrams. What I do is to send a copy to you, Art, which you can then put up through your mechanisms on your website.
Sure.
Which will include a live frame-grabbing animation sequence of the full video or selection on what's listing. And you'll know what you're all looking at. Now, let me back up and explain what's on this tape that most people have not yet seen.
Yes, sir, please.
In the STS-48 video in Australia in September of '91, you're looking toward the horizon, which is roughly 2,000 miles away, and there appear to be, at dawn, as the spacecraft is coming up on sunrise, a series of objects in the field of view looking at us through the rear window of a station wagon. The shuttle is flying backward, so you're looking behind. And on that distant horizon, which is still in darkness, a bunch of interesting dots of light appear, one of which appears above the horizon, moves to the left, and then there's a flash of light on the screen. Actually, it's a double flash, and that object and a bunch of others go in another direction. The NASA explanation for that STS-48 video, which was downlinked live from the shuttle via NASA Select TV that night in September of '91, is that the flash of light is thruster firing, and the reaction of the particles in the field of view is the reaction to little tiny flecks of ice and dust and crud being swept up in the gas entrainment of an expanding cloud of vapor from the thruster. On this new video, what is so striking is that there are no, until the very end, flashes of light. And with the objects appearing in the field of view not only move into frame and then stop and hover and change attitude and motion, but they absolutely, fundamentally, 1,000% violate.
Right. Let me stop you there and see if I understand. In STS-48, the argument is made that the movement that should physically possible of these objects that we see is accounted for because of the shuttle was changing, not the objects.
No, it would have been the puff of gas from the thrusters basically.
Yeah, but Richard, objects once in motion in a certain direction in space should continue in that direction, yes?
That's right.
And if they don't, then you have to account for it by saying, well, the shuttle itself moved, and so our view of that object changed, which I think is what Tom was suggesting was occurring with STS-48, correct, Tom?
Yes, that is what one of the explanations put forward.
Okay, then in STS-80, Richard, you're suggesting...
No, the conventional explanation, I think there's a confusion in terms. For NASA's claim is, see in the STS-48 footage, tiny particles relatively close to the shuttle and the camera that are in sunlight as the shuttle is coming up and are very bright. They're tiny. You can't resolve them as objects, but they're brilliantly lit. So they appear as bright little points of light, diamond points of light against the background darkness. When thruster fired, the expanding wave of gases in the vacuum from the thruster firing accelerates them.
Right.
The shuttle attitude in the field of view does not change. Before we actually demonstrate on the NASA on our own analysis, where we put arrows on the start line, and the angles don't change before and after the so-called thruster firing.
So then these little objects ought to continue in a straight line to where, right?
Well, no. If I think of it as a wind, think of it as leaves blowing in the wind. The reason leaves, wave, outside force, the air blows across them, imparts momentum to the leaves, right?
Yes.
If leaves are falling off a tree...
Yes, but in space no one can hear you scream or there is no wind.
Remember the footage we got when the Skylab astronauts went up to repair Skylab back in the mid-'70s? And they had to put lighting to shield the Skylab space station from the sunlight because things happened on the way up? And footage of the Apollo Command and Service Module approaching, firing its attitude control thrusters, and the Mylar shield on top of Skylab is dancing around in the wind like a Force 10 gale in the vacuum of space. The reason is because it is a vacuum, even a tiny puff of gas from a rocket engine will flow in a straight line at very high velocity and will impart momentum to whatever it touches.
All right, I remember the STS-48 video, and I saw particles take what appeared to be right-hand turns, intercept each other,
and
do all kinds of...
And NASA's explanation was that was in response to the gas coming out of the thruster at the moment of firing. That the particles were moving one way, the thruster fires, the gas comes out, and it blows them all in the other direction.
All right, and that's the one that Tom buys. Now, you're saying in STS-80, you're getting these kind of movements...
without the firing.
Without the thruster.
And it's even better, because you'll see several objects tooling around in the frame which stop and pause and station keep and move in other directions.
No, that's impossible.
Of course it is. Now, what's even more intriguing, and the chief engineer pointed this out.
Wait, let me stop you there and ask Tom. If we were to see that minus the thruster firing, how would you then explain it?
Well, I really need to see the video to make it. Just letting my imagination run rampant. I haven't yet heard a way to allow the possibility that since there have to be thrusters on pointing in at least three different directions, the hearing may not be visible as a flash from that particular viewport. So you wouldn't necessarily the flash, and it still be thrusters. And if they were turn, that might cause the particles to change, either start moving.
Is there any way, Richard, to either rule that in or out?
Well, see, this is what science is. It's a matter of models trying to think of all possible explanations and ultimately zeroing in on the only explanation that fits all the observations. Tom is at an inordinate disadvantage here because I've seen this video and he hasn't.
Right.
I would agree with that.
That was a very valid first attempt. It would be valid except for other observations of the stuff that's going on in the video.
All right.
And you can go through this. Anyway, he is going to have an extraordinarily interesting time looking at this, and I would hope, because of his background in celestial mechanics, he would also contribute to the analysis, and we'll put it all out there, and then we're going to see what NASA says. And they're going to have to come back with some legitimate analysis to match this engineering group, which is currently working on it.
All right. Whether or not these objects are what you think they may be or what they may be. Fact of the matter is, there is a big dispute, and we addressed it last night with several questions to Don Savage and Ray Villard, a video from the shuttle.
Well,
and I asked them about two aspects. One was the cameras inside, which is the S-48 video, and then I specifically came back and asked them about the cameras outside. Gentlemen, I said, are either one of those cameras or the video from those cameras delayed in any way, by seconds or minutes or whatever? And there, at first was an absolute no, there's no delay. Then when I asked them about the other cameras, there was a hesitation, and they said no, as far as we know, no delay. Is that accurate?
You want the long or the short answer?
I want the answer, whatever it is.
It's not accurate.
It's not accurate.
No. Now, the footage on SDA is in the payload bay. You've got this open cavern, which is 15 feet wide and 65 feet long. It's as big as an 18-wheeler. When you pass an 18-wheeler on the highway, on the freeway, you're passing an object that would fit in the payload bay of the space shuttle.
Okay.
That's how big that bay is.
Big.
It's got stuff in it. It's got experiments. Sometimes it has Space Lab. It's got satellites that they launch, whatever. At all four corners, it's got 4 TV cameras, all right, which are outside, exposed to space, outside the cabin, outside the cockpit of the shuttle. They are always running. They are always under control, while 90% of them are Houston. The astronauts can be doing stuff inside, not looking out the windows, and those cameras are sending data through the TDRS satellite or putting it on onboard tape recorders almost all times. And zooming is under control of Houston. The astronauts can be totally unaware of what's going on outside because they're busy. They're doing other stuff, experiments. They keep these guys awfully busy. Actually, they're advanced. So 9% of the time, the astronauts are oblivious to what's going on outside. They're not sitting up there gawking out the windows. They're very, very busy.
Yes. On
this video, what's really astonishing is there's a sequence where the ground controller is so interested in the activity, he zooms in on these objects tooling around in his field of view. Now, I would think that somebody in Houston who's running the camera is holding in front of the lens, right?
Sure.
Why would he be interested in just more crud? The answer is because this crud is doing something that no crud can do. Anyway, before you see it, you can't make a decision. My point in answer to their statement last night is that you have two different modes of handling the TV data from the shuttle.
Well, I know that when they're in there and we get a sort of a lineup of all the astronauts, men and women, saying hi, and it's wonderful up here, and we're having a great time, wish you were here, whatever they say, that's live.
That's live.
All right.
Or with a normal time delay of a couple, 3 seconds because of the satellite link and all that.
Right. That's what they
described last night.
All right. Now
the reason it's live is because it's highly unlikely that something anomalous is going to go flying through the cabin.
Plus, it's got to be interactive.
And it has to be interactive.
So it's got to be live, right? So
it's the cameras outside that after September of 1991, when somebody slipped in one mode of thinking and allowed us to see that event live on TDRS, on NASA Select. From thence on, this is what, 97 now? For 6 years, all the outside cameras have been on a delay, and the delay is almost a full minute.
A full minute.
It's 50-some seconds.
Now, this is a non-trivial difference with what we were told last night by Don Savage and Ray Villard.
Now, again, looked at very narrowly, I can well believe that Don and Ray totally believe the NASA propaganda, because there's no reason for them to ask the question. It's so absurd to consider that NASA would hide anything, that if you're a public affairs officer and you're only told what you need to know so you can go out and stand in front of the press and be believable.
But damn, Richard, this is what the whole argument is about, whether or not we are having things concealed from us, right?
That's right. And I do not think those gentlemen were consciously lying to you when they said they didn't think it was, because there's no reason for them. The guys who would know would be the public affairs people at Johnson, who, as part of their duties, would know, but there's no reason why they would talk to Don, because he's in space science, and they're in manned space flight, and never the twain shall meet.
Yes.
All right? That's the degree of bureaucratization, of fossilization. The way you keep secrets is you create a bureaucracy where people don't talk to each other, and it has to go up the chain of command, and committees have to make huge decisions.
How can you prove that there is an up to 1 minute delay? How can you prove that? Can you?
Yeah, of course.
How?
Because I call certain people in Houston, and I have them provide you the absolute evidence that, in fact, there's almost a minute delay.
Is that an intentional digital 1 minute delay? Kind of like the delay I have here, so I can save my career if somebody says something.
It allows them, and it can be overridden. And what's interesting is apparently the night in December last year when the STS-80 footage came down, somebody made a conscious decision to show that outside sequence live.
All right, hold it right there. I was going to ask about that. If it was delayed, in other words, why did we ever get to see it? Answered it. We'll be right back.
Now, here again, Art Bell.
Well, here we are. My guests are Richard C. Hoagland and Dr. Tom Van Flandern, who is an astronomer. And we will get back to them. We're about to dive into Europa and Cydonia on Mars. So all of that coming up. Back now to Dr. Tom Van Flandern, who is in Washington, D.C., and Richard Hoagland, no doubt, hovering above New York City somewhere. And I think we've got Dr. Van Flandern on another phone line. We tried another phone line. Doctor?
Yes, that's right.
Ooh,
that's much better.
That's much better, yes.
He came in from the asteroid belt.
Yeah, there you are.
Came in from the cold.
All right. Doctor and Richard, I want to talk for a second about... Actually, I want to cover Europa and Cydonia. Wait a second, Richard. I want to tell my audience that your website and now also Dr. Van Flandern's website is available through my website. So, folks, when you go up there, you can link over to either one of these gentlemen's websites immediately. That's www.artbell.com, and we just got Dr. Van Flandern's website up. We just got the link up. Richard...
that must be Scotty Rowland's work.
Oh, of course. Listen.
I can't say too much about Keith, all right? I really should take a moment here and thank him profusely. You know, you have given me a tremendous... because Keith Rowland is the backbone of the Enterprise mission website. And last night, while you're having fun interviewing our NASA friends, Keith is furiously working to put up our very detailed and elaborately illustrated response on our website to the letter that they sent to you.
Yes.
And before they were off, it was up. And he did a neat, brilliant job of highlighting things in color and, you know, putting all the URLs in and connecting the links to the NASA data. And that those folks last night didn't exactly know what they were talking about.
There is nobody like Keith Rowland. That's just a fact.
Yep.
All right, look, Europa. That's one of the things discussed last night. Now, their comment was that the Europa proposals, after all the down on Nightline NASA did, everybody's saying, oh my God, there's going to be life there, there's oceans, there's probably volcanic venting, all the things you said 17 years ago. It's the most interesting place to go to, along with Cydonia. We've got to go to Europa. And somehow the two proposals to go to Europa, in their words, didn't make the cut. Now, that drove a lot of people in the audience crazy. Absolutely crazy. I got a lot of angry faxes about that. How could it not make the cut? Now, they gave their explanation. Did you buy it?
Long answer or short answer?
Short.
No. What's even more appalling is, now this is where Don Savage really should have done his homework, and because he's being paid by us taxpayers, he really should have known what he was talking about. He did not know the contents of the two Europa proposals. And one of them is from JPL.
Oh,
so he made
really?
it sound like he got these 34 RFPs out there, which is NASA's request. and that what came back was, good stuff and not so good stuff and pretty bad stuff, and they kind of winnowed out the bad stuff, and they've now focused in on 5 of the best, and they'll give them help, and they'll give them money, and they'll kind of groom and preen and perfect it, and then they'll pick 1 or 2, maybe even 1 out of those 5 to fund.
Sure.
And what he made it sound like the Europa stuff came in out of somebody's garage here in Hoboken. In fact, one of the Europa proposals was from a splendid team at JPL, and it was designed to get the answers to the questions he was posing that they said they needed before they could go. In other words, there's a very interesting closed loop set of reasoning. I almost got the vision that there'd be a bunch of guys at NASA headquarters sitting in a room holding a seance to get some of these questions before they would commit the money.
All right, listen, they didn't tell us what it was or even that JPL proposed. Now, if you know what it is, tell us, what did JPL propose to do?
The same mission they're going to send to the moons of Mars. The idea was this proposal. I forget the name of the scientist, but he's one of the in crowd. Remember, we've been doing this now for 30-some years, right? As a culture. There has developed a whole subculture, and Tom, please break it at any moment, the aerospace community, where everybody scratches everybody's back. You talk about the old boy network. I mean, this is really the old boy network. And there's only a small group of people who know how to do this, and they all talk to each other, and they all work on each other's projects. And so when NASA puts out these requests, it isn't Joe Blow down the street proposing to go off to look at life on Europa. It's members of the club.
I understand.
Right, Tom?
Yes, that's right.
Now, one of these proposals from a very good group at JPL proposed to send an orbiter to Europa.
Right.
Which would carry along with the orbiter a 22-pound sphere of depleted uranium. All right? Basically an iron ball.
Right.
And the idea was that after you've gone into orbit, you would release the ball, or maybe you'd release the ball as you're approaching. I think that's what they would crash into one of those cracks, those dark cracks.
Right.
Where the suspicion is, in my model almost 20 years ago, and in NASA's model now, that there's brown gunk, there's goo, maybe even little dead beasties coming up from the oceans underneath. And the 22-pound sphere of depleted uranium, from your friendly local neighborhood warheads, Gulf War, etc.,
sure,
would cause an incredible spray of ice and debris and maybe even water. In other words, it would cause an explosion, an artificial cratering event.
Right.
And the orbiter would come around Europa on the first pass and fly through this cloud of created debris and scoop it up and analyze it on the spot, looking for organic goodies.
All right, now they say...
And then beam this data back to Earth. This is the identical proposal that they have selected to do the same thing in terms of the moons of Mars.
All right. Dr. Van Flandern, is there any way in the world that a project that goes to the moons of Mars to do what Richard described is anywhere nearly as scientifically interesting or compelling as going to Europa and doing it?
Well, in view of what we've learned recently, of course, the situation has changed drastically. But I think that if during the time period when these proposals were being reviewed, that was before the finding that Europa looks as though it really does have an ocean there that could be life-bearing. And it's almost as if that was before its time, before the time was right. And proposing to do that and proposing to look for life, it looked kind of far-fetched at that point until the Voyager spacecraft, the Galileo spacecraft, changed the whole equation.
Yes, sir. But at the time they made the decision that it didn't make the cut, they already knew how exciting Europa was. So, again, my question is there any way that you can understand why this didn't make the cut and going to one of Mars' moons is more interesting?
Well, I'm sort of saying I don't think that premise is right, that the reviews were probably in months ago, and the decision had been made but simply not announced.
Oh, I see. Well, then, are you saying that NASA is such a big bureaucracy, incapable of changing in the face of new information, that they couldn't change their mind?
They had probably, by this point, already communicated to the winning teams who had won, and it was probably too late in the game to go back and redo it.
So then we're continuing at the risk of disappointing a couple of guys who thought they had won.
I mean, I'm speculating on
and I think you're being very charitable, Tom. You're really bending over backwards to paint the most charitable view of this. Let me tell you the facts.
I'm a lot more interested in the science than I am in who gets disappointed about their project.
Even under Tom's assumptions, it doesn't wash, and I'll tell you why. Remember the heads up I gave you about Stephen Squires and the conference last spring in England, where Stephen Squires, Carl Sagan's protege from Cornell, was at this conference basically claiming to have invented the Europa proposal years ago.
Mm-hmm.
Remember our show we did on that?
Yes, I do.
And the web stuff and the letters that came in from academics and the question, Dr. Squires, isn't this close to plagiarism? What about Hoagland's paper, et cetera, et cetera?
I recall.
NASA, deep in the halls of NASA, has known Europa is stunningly important and interesting for the entire lifetime of these proposals. They just didn't learn about it on April 9th when the world got to see the excitement. This has been bubbling, pun intended, beneath the ice for months and months and months, for years, all right? So the idea that this set of proposals was not tailored to take full advantage of the most extraordinarily interesting suspicions and to advance the story. Remember, Galileo is a remote sensing probe. It's only able to take pictures and spectral data from occasional flybys, even during now the 2-year extended mission.
Mm-hmm.
What is needed next, and Wes Huntress, who was the head of science for NASA, sat on Koppel's show the other night and said they were going to do next, is go into orbit and use all kinds of neat instruments to try to find the weakest parts, the thinnest parts of that ice, and maybe try to do some kind of sensing or analysis of what the gunk is, the dark brown stuff around the cracks, to see if it's organic. That's exactly what this proposal was designed to do. No matter how you slice it, there's something very weird going on here politically.
Okay, well, cutting through the crap, does this mean basically that NASA doesn't want to find life?
No, I think it's even worse. I think NASA wants to find it but not tell us. I do not for an instant believe that they have lost any interest in Europa. They're not dumb. They're not crazy. They're just crafty.
Doctor, are you that cynical about NASA?
No, I'm not. I don't rule it out as a possibility, but I think it would that's a problem that would require too many people to participate in the conspiracy, and you wouldn't be able to hold it together.
No, it doesn't, Tom. All it requires is somebody at the top saying no to this proposal.
Okay, that's what they said last night. They offered that up. They said, look, anything that big, that exciting, could no more be contained than the man in the moon.
Well, see, this is where it's very important to look at this STS-80 video. Because if, in fact, it's not ice crystals but spaceships that we're seeing,
yes,
and somebody in December wanted us to see the secret space program, and it's our stuff. It's not aliens, it's not ETs, it's our spaceships.
Okay, let's go with that.
Paid for with a black project and a set of data that is not normally privy in the astronomical or scientific or engineering community. Then you can easily do the kinds of follow-on experiments using one of those things to zip out to Europa, and NASA need not apply.
Doctor, do you buy the premise that Richard just put forth? That is that we have all kinds of capability, anti-gravity craft capable of speeds that we can only imagine or hope for in the far distant future, that we have all that right now, and we're using it, and that the present space program is sort of just a big sham.
That's a lot to take in. If the main evidence for that is the STS video, I'm at a disadvantage of not having seen the latest. Well, it does seem that it's quite a leap of faith to adopt all of that as more than just a hypothesis.
Well, I'm only proposing it as a hypothesis, but look what it explains. What you have is a public program funded to the tune of about $15 billion a year, which basically is funding a whole bunch of cronies and in-crowd, and circulating contracts, and outsiders need not apply. It's a make-work program for grad students and aerospace people and aerospace companies. One company, Lockheed Martin, has 65% of the total aerospace budget. One company, 65%. That's astonishing monopoly, all right? And these are public figures. If you read Adweek, these numbers are available. The fact is, Tom, that if we had a two-tier program where you had a military group behind the scenes developing stunning technology which, flies rings around Newton, and you had a public program based on Newton's first and second and third laws, meaning rockets, never the twain need meet.
Well, then we are risking lives unnecessarily in the rickety old Mir, putting our astronauts in a very old space station for what reason?
Well, no, because if they really get in trouble, you can go and rescue them quietly with this other technology.
Doesn't that require a lot of people, though, to participate in the conspiracy?
Yeah.
No, it requires a black program where you're on a need-to-know basis and only a small elite group like the Skunk Works. We've had technology flying around the skies of this planet that the general population, the general engineering community, the general scientific community had no hint about for decades. Now, if you can do that in Palmdale, all right, in North America, what happens if you base an even more interesting elite group using very interesting technology in physics somewhere offshore, maybe Australia, all right? My point is that if you look at this video and you come to the conclusion that what you see on this is not ordinary stuff, but is definitely some kind of space vehicles, in plural, tooling around with very non-Newtonian physics, then all bets are off. And
well,
if they're ours...
I agree with that, Richard, but I find it a stretch, as does the doctor, to imagine that they are ours. If they're doing non-Newtonian type things, I would more easily buy the model that they are from elsewhere than I would that we have some great secret sub-program.
Well, because you haven't followed the work on electrogravitics for the last 30 years.
Well, that's probably true. Anyway, everybody hold on. We'll be right back to this. And when we come back, we're going to move from that to Cydonia, that region of Mars that Richard is very familiar with. The face, the artifacts, those things. From the high desert, you're listening to the CBC Radio Network. Good morning, everybody. Dr. Van Flandern. Tom Van Flandern is my guest, along with Richard C. Hoagland, and we're discussing a few differences here. I think Dr. Van Flandern is going to have to plan on staying around a little bit because I've got a couple of questions that are probably going to absorb this half hour before we properly get to Cydonia, which is a very, very, very serious subject all by itself. So in a moment, a couple of pretty serious questions. Gentlemen, I want you both to listen to a fax I got, which blasts you both in a way, and then I want your answer, okay?
Okay.
It is as follows. Your guests are being deceptive. If these clowns, faxer's words, don't want to mention Comet Halley, I will. In March of 1986, 3 spacecraft swung by Comet Halley. Vega 1, Vega 2, and Giotto or something. Giotto, must have been Italian. All took many images of Comet Halley's nucleus from both long range and close in. As a matter of fact, Giotto was able to resolve features on Comet Halley's nucleus down to the 200-meter level, and not one, repeat, not one of the many hundreds of images taken, both near and far, revealed anything other than one solitary nucleus, 16 kilometers by 7.5 kilometers by 8 kilometers. I can understand Richard not wanting to mention this hard data, But your astronomer should be ashamed of himself for withholding this information from your listeners. Don't take my word for it, though. In-depth articles on Comet Halley flybys can be found in March 1987 issue of Sky and Telescope and the June 87 issue of Astronomy magazine. Would you have both of these gentlemen comment on this?
Well, first of all, let me say that I appreciate this faxer. He makes some extremely important points, and it's only because we have so much to cover, and the clock is ticking, and you wanted to cover several different subjects in moderate depth as opposed to great detail.
Sure.
That Tom and I have not gotten into this. But in fact, this is a pretty astonishingly interesting example of where Van Flandern, in fact, could be right. And I'll let Tom start, and then if there are any things to fill in on, I will add a couple of tidbits. But this is a very interesting case of where the exception may prove the rule.
All right, Tom?
Okay, well, the key point that your listener was making was that the pictures only show the one solid nucleus.
That's right.
And not other large satellites in orbit.
Correct.
However, he's not appreciating the contrast problems when observing inside the coma of a comet. There is so much light flooding the whole area that there's very little contrast there, and the camera was tuned into the nucleus of the comet. Now, if you had a satellite, let's say the nucleus of Halley was about, let's say, 10 kilometers diameter. If you had a satellite 1 kilometer in diameter, that would be 1/10 the diameter of the big nucleus, 1/100th of the brightness. That's 5 magnitudes fainter. There's no way in the world that the spacecraft would have been able to see that object in that coma. And that's as big as the satellite of asteroid Ida.
All right, so what you're suggesting in layman's terms is anybody who works with video camera knows when you take a picture of a very bright object, you get a blooming effect. And you're
suggesting... it's even worse. It's like taking a picture of a bright street light in a London fog.
Yeah, okay. I understand that.
Fog is the coma. The coma is this atmosphere of escaping gas and dust blowing off the object or objects at the center of this cloud. It's basically a planet outgassing an atmosphere without a gravity field to keep it attached to itself.
Right.
And so the atmosphere just keeps escaping and is blown back by the light pressure of the sun.
Isn't there one other thing that's possible, gentlemen? And that is that both models are correct, that some comets are singular while other comets may have pieces orbiting each other. Aren't both possible?
Well, the short answer is of course, but it's more interesting. If you look at Halley's orbit, Tom, jump in any time here because you're the expert on the celestial mechanics. Halley's orbit now is a short period. It's 75 years, right?
Yes.
That means it's made many, 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 many trips around the sun in the inner solar system before we, the human species, arrive to see it, to photograph it, to send spacecraft to it. It's an old, very changed object by virtue of this very brief period. Hale-Bopp, for example, had a period of 4,200 years, and we know it's now been changed to 2,400 by the recent pass through the inner solar system. Yakutaki had a period of 63,000 years when it tracked by the Earth last year. Kohoutek, I believe if my numbers serve me, had a period of 1.5 million years, give or take a few million. So Halley, while it was a wonderful historical object, in terms of being an average representative of the class of comets that Tom and I are most interested in, which is the ones that have not been changed, it is a very poor representative of the class, first of all. Anything I've said you would disagree with, Tom?
No, but on the other hand, just talking about the satellite model, I think I don't have too much doubt that there are satellites in orbit around the nucleus of Halley. On the positive side, for example, I thought when you mentioned period, I thought you were going to talk about the period of rotation.
No, I was thinking the orbit. But go on to rotation if you want.
Well, yeah, the period of rotation, several different numbers arise from the analysis, and they're talking about all kinds of chaotic motion and precessions and so on. What they're actually seeing, of course, is a mix of the actual spin of the nucleus and the orbiting of various objects around the nucleus.
Mm-hmm.
The other problem is that with a short period of comet, and people probably think that 75 years is a long time, well, it is for a human lifetime, but for celestial events, it's just an eye blink, all right? That meant that comet, Halley, and we know that it has been changed in terms of its orbit, had to have interacted at least once with one of the major planets of the solar system, right, Tom?
Mm-hmm.
If it did a Shoemaker-Levy 9, if it came close to Jupiter or Saturn on its way in the first time or the second time or the 10,000th time, then that close approach could have stripped off most, if not all, of the satellites, leaving just one object. In other words, Halley is not a good example, and it's the only one we went to because of the historical politics of the missions, not the true science of the missions.
All right. One of the questions that I asked the two NASA gentlemen last night was, if the equivalent of Shoemaker-Levy 9 were coming toward Earth, could we have done anything about it? And they paused and they thought, and they basically said, nope. You know, we might have done something to a piece of it or pieces of it, but basically we would have been impacted, and if we'd been hit by pieces like that, it would have ended all life. You gentlemen agree?
I would like to say first in answer to that, that Jupiter makes its own problems in this regard. It's like a giant vacuum cleaner out there. Jupiter's gravity is so intense that it grabs everything. If Shoemaker-Levy 9 had come by Earth at the same distance, that's approximately the same distance as Hale-Bopp now, we'd hardly have noticed.
However, it is possible that something could be on a trajectory that would hit Earth.
Not only possible, but it happened in 1913.
Right. Tunguska?
No, that was in 1908, wasn't it?
Yeah, I'm not speaking of Tunguska. I'm talking about our Shoemaker-Levy 9 here on Earth, which happened in 1913.
Oh, the Cyrillids.
The Cyrillids, yes.
I don't know
about that. No one knows about them. Tell Art.
Yes, please.
It was a streak of meteorites that came one after the other over a period of 5 or 10 minutes from northwest Canada down across the Midwest, the northwest U.S., down the Atlantic coast, and they finally plopped into the ocean off the coast of South America. It was one right after the other, and it was a puzzle for a long time how that could be. There's so many synchronized objects. But now that we have the Shoemaker-Levy 9 model, it's quite clear that, again, it was a case of something making a prior pass, breaking apart into a number of objects.
In a line.
Yeah, in a line. By the way, when I'm using the expression breaking
when you
apart
say breaking
loosely.
Apart, you don't mean breaking apart.
Yeah, just escaping of satellites gravitationally bound to the nucleus.
See, one of the things that Don and Ray did last night was to provide confirming data for Tom in their discussion with you, and they didn't even know they did it. Remember how they were talking about the various resolutions of Hubble?
I do.
And what it could not do. By the way, I've been sitting here with the Hubble data, calculating in the breaks the actual resolution of Hubble in terms of Hale-Bopp.
Okay.
Remember how the Lord told you that they could resolve 13 miles
Yes.
for 1 pixel
That's correct.
on Mars at the current opposition,
Correct.
which is 60 million miles away.
Yes.
It's, in fact, closer than 60 million. And the best opposition for Mars is 35 million. But let's just assume his numbers, all right?
Okay.
For a moment. It turns out that they're woefully wrong, but we'll assume them for one moment, all right? If you assume a resolution of 13 miles for Hubble at 60 million miles
Yes.
as the smallest object, then at 93 million miles, which is 1/3 farther away, the object you could see, the smallest object, is 1/3 bigger, right? So it's 1/3 bigger than 13.
Right.
So it's on the order of maybe 20 20 miles, right?
Okay.
Well, if Hale-Bopp was supposed to be 25 miles across, it means that even giving the large numbers, which I can prove are wrong, Hale-Bopp could have imaged the nucleus of Hubble could have imaged the nucleus of Hale-Bopp and seen it separate from potential satellites. What you really need is a realistic model of how the satellites are orbiting the nucleus, or the biggest chunk. And what Tom and I have really had an interesting set of convergence on is that the idea that you have a solid lump, like a peanut, orbited by other little separate lumps, and you kind of look at them and you'd see one frozen snapshot of one big guy and a bunch of small guys. Wrong picture. A much better picture is one big guy or a number of big guys together orbited by a cloud of smaller pieces in a lenticular flattened nebula very similar to the forming solar system, or very similar to photographs of galaxies, a spiral kind of flat plate-like object.
All right.
That could have been overwhelmingly photographed by Hubble. In fact, there's some occultation data that was acquired in March of last year, Tom?
Well, yes. Which are you thinking of?
I'm thinking of the March where they put 7 teams out in northern Oregon.
Oh, yes.
To measure, Don Yeomans at JPL had calculated that Hale-Bopp would cross a fairly bright star, that the nucleus, where they thought it was, would actually occult. Eclipse a background star. And since asteroid satellites have been detected from Earth by that technique long before Galileo photographed Ida and Dactyl, there were some people looking to see whether they could actually measure the size of the nucleus by this occultation technique. Years before, the rings of Neptune were spotted from a group, I believe, at Smithsonian, was it, Tom?
Yes.
Using the same technique. Anyway, they fielded a team, and all of the team except one was clouded out. And the one team that got good data, they don't believe their data. The reason is that the occultation went on for 10 seconds. Now, this was when Hale-Bopp was supposed to be not far inside the orbit of Jupiter, right?
In other words, not repeatable, not documentable.
No. It was the length.
Yeah, that's what I'm saying. In other words, it was not repeatable. It was a very short duration.
Well, you could look at an occultation. No, 10 seconds is a huge duration. Tom, tell him what we're going for here.
That implies something much, much larger than any possible single nucleus of the comet.
Right.
Something on the order of 200 miles across.
Wow.
In other words, what I think is going on, and what we could have confirmed if we got the right Hubble shots, is we're not looking at a nucleus and little guys flying around it. We're looking at a disk of material. And the occultation that this team in Oregon spotted and recorded photoelectrically and has published, although they don't believe it, may in fact have been the occultation of the disk of material orbiting in the equatorial plane of Hale-Bopp.
By the way, the starlight just dimmed. It didn't go completely out. So.
Wow. Which, of course, is what a disk would do. It would filter the starlight but wouldn't block it completely because it's little tiny particles and big chunks randomly interacting.
Yeah.
It's like a cloud.
All right.
In other words, every piece of data we've got is telling us that Tom could be right, and the tragedy is that the guys in charge of the big instrument that could have told us have decided it's not important.
Well, they would say it wasn't worth the risk. They did say that. That's what they said. Again, before leaving Shoemaker-Levy 9s, if something the size of Shoemaker-Levy 9 plowed into Earth, or whatever pieces we couldn't blow out of their trajectory toward Earth, plowed into Earth, what would have happened, Tom?
Well, we would have had a scenario such as happened supposedly to end the dinosaurs and 70% of the species on Earth at the KT boundary. I think that event was an earlier planetary explosion, probably the parent planet of Mars, in fact, and we got hit here on Earth with quite a number of chunks of debris right around the same time. But whatever the cause, it was pretty catastrophic for the biology on the surface of this planet.
All right. We're getting close to the top of the hour here, Richard.
Oddly enough, your question brings me back to STS-80.
All right. How?
Because if the objects on this shuttle video, this official NASA video now,
Yes.
are in fact spaceships, and they're ours, and they are able to violate known laws of physics by control of gravity, then obviously if you spot something coming, you send up a couple of those guys, they nudge it out of the way, and the problem is solved.
Absolutely.
And it can be done in an afternoon.
Absolutely.
Now, if they're not ours, if they're ETs, all right, let's run the scenario out there. What does this do for us? Well, the first thing you do is you put in a phone call. And you try to get them to run out there and divert this object.
Right.
Number two, if they won't answer the phone, the very fact that the technology, that physics exists, means that we should be declassifying all black programs looking at electrogravitics, which I know exist, because that technology is critical to the maintenance and preservation of civilized life on planet Earth.
All right, Richard, we are going to discuss coming up Cydonia, but somebody writes, is there anything germane in your mind with regard to Arthur C. Clarke's great warning to, in effect, not mess with Europa?
Tom?
No, I think the
dear
short
Arthur.
answer to that one is no. That was it was great science fiction, but no, it was just it was like who was it? Jonathan, the prediction of the moons of Mars before they were discovered.
Jonathan Swift.
Yes. It was just an inspiration by a well-educated, well-informed, and very creative writer.
Yes, but it points to the high probability in his mind when he wrote that science fiction of life, of Europa being the one place where life is most likely, other than Earth, to exist.
Well, no, wait.
Is that fair?
Arthur and I have known each other a long time, and obviously I know the background of 2010. Arthur admits that he developed 2010 as the successor to 2001.
Correct.
Based on my idea, life in the oceans of Europa.
Yes.
And what he did was to follow his previous model, which was 2001. I mean, what's the thesis of 2001? That the human species is the product of intelligent alien intervention as an experiment, and the experimenters have certain parameters and boundaries.
Well, they had certain markers that were to be found if we evolved as they hoped that
right.
we would.
Where we would find out
the
we were, in fact, the creation of
yes.
the creators.
Yes,
right.
yes.
In 2010, having given him this neat new place where life could be cultivated
yes.
in the solar system other than the Earth,
right?
He extended the idea to the experiment going on at present on Europa. The warn-off was not because of Europans not wanting company. That was the new place where the experiment would be continued, and that was the reason.
Okay, well then the answer to my question is yes, Richard. In other words, it is the next most likely place where life would be.
Yeah, but you're missing my point, which is
no, I'm not.
In Arthur's scenario, in the tradition of the Future History series of 2001.
I understand his science fiction presentation of
right.
it, but it still is within the model of it is next most likely place where life would be or might form.
Well, yes, and I could spend a whole program discussing what kind of life I really think is waiting for us there, and that gets back to why is NASA doing exactly the opposite.
All right, hold it there, Richard. We're at a break point. We'll be right back. This is CBC.
Now, here again, Art Bell.
Straight ahead, Cydonia. All right, back now to my guest, Dr. Tom Van Flandern. He is an astronomer. PhD, his PhD from Yale in 1969 in celestial mechanics, and he specializes in origins of things like comets and meteors and man. And, of course, Richard C. Hoagland from Manhattan, and they're both back. And what I would like to talk about now is, I guess, what got you started, Richard. Doesn't this really trace the beginnings of what you've done, the face on Mars, the artifacts in the Cydonia region? Is that fair to say?
Well, remember, I had a life, even a professional life, before Cydonia, before Mars.
Right.
I was in the museum field. I taught astronomy. I was a science advisor to the network, to CBS, to Cronkite.
Sure.
I covered the space program. I was an advisor, to NASA at Goddard. I did the history of the orbiting astronomical observatory program for them. I have a deep and abiding interest, even a love, I hope I would say, in all things astronomical, which includes where we came from and what we're all doing in this place.
Okay, but you
began... So it was a natural segue when the Mars data came my way to continue to ask questions. I'm a curious person. I want to know the answers.
But that's when you got out on an astronomical limb.
But that's a political problem. In fact, I'm just keeping on keeping on. I'm going to know what I can find out.
Okay.
I'm going to apply the best democratic science techniques and tools that are available to find out. Now, if anyone had told me 15 years ago, in '83, when I started, that we'd be sitting here tonight and Tom and I would be discussing data affirming his model, which connects to my interests, after Cydonia and the artifact quest and all that, on your radio show with an audience of 15-plus million people who are hopefully interested and intrigued, I would not have given high probabilities for that set of events. But that's the convergence which is coming down the pike. Tom's data and Tom's interest are converging with my data and my interest, and that's what real science is supposed to be about.
In some areas. Now, let's see if they converge with respect to Cydonia. Last night, my guests from NASA, I asked them about Cydonia, the face on Mars. And, of course, in the beginning, as we all know, NASA said, no. Tricks of light and shadow. We're sending a new mission to Mars.
2 new missions.
2 new missions, excuse me. We have an opportunity now, I hope, to finally resolve the question of the face on Mars and the artifacts in that area of Cydonia. However, they seemed rather unsure last night of whether or not we would resolve it, whether or not we would get images of the Cydonia region.
No, well, I wouldn't bet the farm on it either.
It's pretty much of a long shot. That is, the Mars Global Surveyor will map the whole surface at a medium to low resolution, no better than the resolution of the pictures we already have. But the high-resolution camera is estimated to only be able to photograph 1 to 3% of the entire surface of Mars.
Which means you got to want to take the pictures. Otherwise, you're not going to get them by accident.
Can they get the high-resolution pictures of Cydonia on purpose?
There are ways that the orbit could conspire against them and never overfly that area, because the camera can't be pointed. It always looks down, straight down. So the spacecraft orbit has to take it over Cydonia, but the odds are that will happen a few times during the 2-year mapping mission. So they should be able to get something in the Cydonia area.
Well, now, wait a minute. You're confusing me. You said that there was only a 1 to 3% chance that the high-resolution camera would take pictures.
No. If you look at the whole planet, all right, Mars is 4,200 miles across, okay, which is half the size of the Earth. But it has no oceans at present, which means if you do a calculation for the total land area, Tom, help me on this, okay, it's equivalent to the total land area on Earth. That's a huge amount of real estate. To get high-res, that is 2 or 3 meter data, which is 6 or 8 feet data, all right, for the smallest thing you can see, of more than 1 or 2% is going to be pushing it in the 2-year life of the expected mission. Just because of computer time and bandwidth and pointing and all those things.
Well, just to fill in the details a little bit more, the spacecraft will be in an orbit that takes it over both Martian poles every time around. And,
which is every 2 hours, roughly.
Every 2 hours, and it will always be flying relative to day and night on Mars, such that during the daytime passes, it'll always be 2 in the afternoon Mars time. As it flies over, during the course of the 2-year mission, it will probably have of the order of 6 to 12 overflights of somewhere in the Cydonia region, but the high-res camera is only able to take a strip maybe 1 kilometer to 1.5 kilometers wide, so it could easily fly over, say, the pyramid there, but miss the face or one of the other artifacts. But flying over them and the images going into the camera doesn't get the images to Earth at all, ever, because the high-resolution data is so many bits, so many pixels.
It chews up so much memory.
It chews up so much memory. It can't be stored on the tape recorder for a whole strip. You can only take a 25-kilometer strip of data on a whole flight from pole to pole. So they have to select which 25 kilometers on that particular pass is going to be remembered and sent back to Earth, and all the rest is thrown away.
I've got you.
It reminds me of that joke about light bulbs in Marin, California. How many psychiatrists does it take to change a light bulb in Marin? Only one. But the light bulb really has to want to change. In other words, NASA really has to want to take a picture of Cydonia to get it. And from everything that McDaniel and Tom and I and all the other people on these disparate teams can find out, they don't really want to take these pictures.
No, they don't seem to want to. Although, Richard, and I think you're the one who made mention of this, Daniel Golden, did acknowledge on a program not long ago that even though they might not feel scientifically there is a compelling reason to be sure they take a picture of Cydonia, the American public is wanting them to do that very much, and they're taking that into the equation now in their decision-making. Yes?
Well, again, we come back to the politics. Yes, Dan Golden sat on the Freedom Foundation Forum last November, as Mars Surveyor was leaving for Mars within a couple of days, and saying all these neat things about, well, we don't always agree, but, you know, NASA must be responsive, and there are taxpayers who really believe this stuff. Wink, wink, hint, hint, giggle, giggle, all right?
I know.
And if we can, the operative words here, Art, is if we can. They have given themselves enough wiggle room to fly the Enterprise through.
Yeah.
And I have never seen in any other discussion of acquiring data where NASA has made so many caveats for why they can't do something.
Yeah.
It's incredible.
All right, Richard.
Now, what they have said is that they will target the Viking landers set down in 1976. Now, this is just common sense, all right? The Viking landers are little tiny things,
right,
smaller than this living room. You know, they're almost like 3 or 4 coffee tables put end to end.
All right, but you're getting ahead.
Photograph them.
Richard, now you're getting ahead of us. Stop. I want to ask Tom. Tom, you've looked very carefully as a person can look at the images we already have of Cydonia.
Yes.
You know what Richard believes with regard to the geometry of the various objects at Cydonia.
Well, that's not where I was going.
Well, I know it isn't.
What I was going to say
this is where I'm going. I want to ask Tom, Richard. Hold on a second. I want to ask Tom if he agrees that there is enough scientific validity to the geometry that you have explained, Richard, to make a compelling argument for high-resolution imaging or any other project to go there. Do you agree with that, Tom?
Yes, I do. I think that the case was available almost from the first time the face was noticed, that we should take a look at that region in high resolution at the very next opportunity. But interestingly, although my opinion was the truth of the matter could go either way, artificial or natural, up through very recent months. Your show and my last appearance as a guest of yours has influenced this matter considerably, because we talked then about Comet Hale-Bopp and the exploded planet hypothesis as the origin of comets.
Right.
And I mentioned that Mars was probably a satellite or moon of the planet that exploded 65 million years ago. And one of the evidences that was the case. There are quite a few. Was evidence that the pole of Mars has undergone a rather extreme and sudden shift in the geological past. And that would have happened if a planet had exploded in its face. It would tip the pole of Mars. Well, one of your listeners wrote to me through the website and said, gee, what about Cydonia on Mars, the face and so on? He said, if those things are artificial, then a civilization built them. If a civilization built them, maybe the explosion is what ended that civilization. He said, with that line of thinking, he asked a very innocent question: where was the face on Mars before the pole shifted? And I thought that was a very interesting question, and I went and looked it up and did the calculations, and I was absolutely floored by the result. The face on Mars in the whole Cydonia region was right on the Martian equator before the pole shift.
Wow.
Not only was it on the equator, which is where you build something if you wanted to attract attention to it.
Yes.
Not only that, but the present face is tipped some 20 or 30 degrees off vertical, but the orientation of the face before the shift was perfectly right up and down.
Tom, how can you know that? In other words, how can you know that where the present face is would have been prior to the explosion on the equator? How scientifically, in simple terms, can you know that?
Martian geologists have studied the surface of Mars, and they have discovered a couple of other locations on the surface of the planet where the north and south poles were at some previous time in the past. Astronomer Peter Schultz has published this in, among other places, Scientific American magazine in 1985. This was not in connection with Cydonia or anything else, just in the investigations of the surface of Mars. So the former location of the pole is a published, known place. And no one had ever thought that there was any connection between that and Cydonia until your reader stimulated that investigation, and we did the calculation and found out that the face on Mars is at a set of coordinates on Mars that are exactly 90 degrees away from the location of the old Martian North Pole that was published 12 years ago.
Wow.
Now, this is a very important connection point for our investigation.
I understand.
The Enterprise, because what it does is provide a real testable link between the artifact hypothesis and the exploded planet hypothesis.
Yes.
And another reason for A, getting new pictures of Cydonia, and B, getting better data on comets like Hale-Bopp.
Well, what is more interesting on Mars than Cydonia from a scientific point of view right now? Anything?
Not to, I think, the two of us.
This is where it comes back to the politics. Because what we're seeing happen with NASA is they're treating Europa now like a younger version of Cydonia.
Understood.
As soon as you find something really neat and interesting,
then they don't want to go there.
In accordance with their raison d'etre from their foundation, from their beginnings, the search for life out there, somewhere, some real evidence, what do? They run at warp 9 in the opposite direction.
I do understand. Tom, if you detach yourself from your wanting to prove your model, if you're able to do that, I don't know whether you are or not, but and look at Mars objectively from a scientific point of view, and you were going to send a craft to investigate, truly, is there any other area of Mars that bears more scientific interest than Cydonia? He asks again.
My answer to that, in view of this new evidence, would be no. That's the place where I would put the highest priority. But Mike Malin tells me that everybody who approaches him has his own top priority, and wants to put that way above, at the...
Sure. Well, okay, then if there is a compelling argument, I know damn well NASA's listening this morning. If there is a compelling argument against what you just said, since NASA seems inclined to write me letters, write me a letter and give me the compelling argument. And we are now approaching a reason for a good debate between you gentlemen and NASA with regard to Cydonia and with regard to Europa. Richard, you said they start running in the opposite direction. Well, as a average guy out here, I look at it the same way. I'm sorry, I look at it the same way. They're going the exact opposite direction. The minute they discover something really interesting, they want to go somewhere else.
If there's life attached to it, and that's the pattern. And remember, science begins in patterns. It was so interesting to listen to Savage and Villard on your show last night because out of their own mouths, the thinking, the raison d'etre for NASA's current decision-making was so obvious. And it didn't take me or Tom or anybody else to try to describe what they're doing. What they're doing is right out in the open, and it's the antithesis of what they claim they want to do.
Mm-hmm.
Every time NASA goes to the Hill, all right, with a variety of different mission options to get money, what's the one common thread that they always somehow wind in to their request to the American people for money to go and do things? The search for life.
Sure.
NASA's Origins program. Dan Golan is sitting on every television show in front of every congressional committee saying, oh, we're going to build huge, neat telescopes to find planets like the Earth around other stars. Well, how about finding a planet like the Earth right in our own backyard called Europa and going?
Yeah.
All right? Or they'll send a mission to Mars. And inevitably in the press release, they'll talk about, you know, a place in the solar system where life could have originated and we might find fossils. Or they'll look for meteorites in the Antarctic, and they'll look inside and they'll say, oh, look what we got. Nice, safely dead, 3.5 billion-year-old little microorganism.
Oh, you're exactly right, Richard. And, Doctor, hold on. We'll be right back to you. Bottom of the hour once again from the high desert. I think we now have a reason to have a reasoned adult scientific debate between the gentleman you're hearing now and anybody else from NASA about what the priorities ought to be. What do you think, folks? I'm Art Bell. This is CBC.
And now, back to the best of Art Bell.
From the Kingdom of Nye, Coast to Coast AM continues with Art Bell.
Going back now to my guests, gentlemen, I think that based on what we've just heard, that we have a reasonable opportunity to invite NASA into a debate about both Cydonia, the amount of interest and the compelling reason to go there and to take photographs, and Europa, and to invite them to a debate. Would you be interested in doing that?
Yes, that'd be fine with me.
I'd be interested. The problem is you have to pick which part of NASA and what they're responsible for. The only guy who's really responsible for everything is Dan Golan.
Well, then let's invite Dan Golan.
All right. Now, Dan Golan has said on the record at the Freedom Foundation that Cydonia is going to be reimaged if they can because of public interest.
Yes.
If our audience out there tonight really wants Dan Golan on your show, addressing this audience with all the reasons that he thinks it should be done and what he's doing to make sure it's going to happen.
Here goes his fax machine again.
Exactly. They should fax him at, shall we give out the number?
Oh, yeah, sure. It's I should tell everybody it's a public fax machine, so don't
fax number.
Don't feel
you paid for it.
Right.
You are paying for the fax paper.
Right.
202-358-2810.
All right, I'll give it again. Richard, he said because of the public interest. The debate that I would like to have here with you reason fellows is not public interest, but scientific reasoning. And in other words, a very compelling reason scientifically. Forget the public interest, the face looks cool, everybody wants to know more about it, whether it's real or artificial, whatever. But I asked Tom Van Flandern a little while ago, is there any place more interesting on Mars to go to or to look at? And he said, no. So that's a scientific answer. It has nothing to do right now with public interest. It's science. So if we have a debate, let's have it about science with Dan Golan. Does that make sense?
Well, the person to then have that debate with, and Tom, again, correct me if I'm wrong, would be Michael Malin. Mike Malin is the sole arbiter of where that camera is pointed and what it prioritizes and what data is acquired.
That's right, and Mike is an independent contractor.
Now, they've set up, Golden and Company have set up the contracts with Malin. So basically, Malin is his own czar.
Well, then Malin,
He is not answerable in terms of his contract to anybody at the agency up to 6 months or a year.
No, but the American people certainly would like to know that he's answerable to good science. Wouldn't they?
Yeah, of course they would.
Okay. Well, then a good debate on the science of this. In other words, if Mr. Malin has answers that argue well with what Tom has said, I would like to hear them. If there's another place on Mars that is more interesting for any reason whatsoever to go to, scientifically, then I would like to hear what that reason is.
But you see, this is a false question. It's not about either or. It's not do Cydonia or do nothing. You can do both. We're not being unreasonable. Stan McDaniel, in his list of criteria for prioritizing, Cydonia and the face and the pyramids and all that, has not made unreasonable claims about bumping this up to the most important target. We would just like it to be in like the top 5 or the top 10. And if out of that 1% of high-resolution data of the whole planet in the 2-year mission, you prioritize that some orbits are going to be devoted specifically to Cydonia, you clear the memory, you make sure you got the targeting down, you know when it's going to come up, you're going to make a really good NASA-level effort, the kind of effort that got us to the moon before you know who, then it will happen. NASA is a can-do agency. The folks in the trenches, men and women, when they are given a clear goal, they can make it happen. Over and over again, they have pulled miracles, rabbits out of hats where nobody would have given them any odds they could have pulled it off.
Well, I think the reason that NASA wrote me the letter is because we are touching nerves. That's why. I mean, they obviously don't want a bad public image, and I don't blame them. They're a public agency. Of course they don't want a bad public image.
The fact is
they are afraid, Richard, to come on because they're afraid it will degenerate into some sort of name-calling, you're hiding this, hiding that, it's a conspiracy, and they don't want to have to respond that way. But if we could have a good, scientifically based argument about what should be done...
Wait. Let me back up here. NASA is a government agency.
I understand.
Like every other government agency, they are ultimately accountable to the American people. All right? Just because they're dealing in a technical area doesn't make them any less accountable or any less subject to the potential criticism that their stated agenda is not in consonance with their real agenda.
Yes, I know. But that, but with regard to Europa and Cydonia, the argument or the debate, better said, could be purely on science, right?
That's right, it could, and you could act as moderator and make sure that people don't interrupt one another or hurl insults. Keep it on topic and on science and on merit.
That's my idea.
I mean, you'll notice that Tom and I do not agree on everything tonight.
Right.
But we both respect each other, all right?
That's right.
It's because we're both following a process, or we're trying to. And what we're simply asking NASA to do is follow a process.
All right, but what I think they are concerned about, Richard, is that I'll be the NASA guy, you be Richard Hoagland. That's easy for you. They're afraid that I'll have to sit here and you'll say, look, you guys have been lying to the American people. You're lying to them now. You have spacecraft that are zipping around out there and can do all this stuff. You have anti-gravity. You have all the rest of it.
And
you're hiding that from the American public, aren't you?
Art, I've never said NASA has anything like that.
Well,
No, I did not.
That we, the human beings, have it, all right?
I have said that we have a compartmentalized government that for the last 30-plus years has been devoted to an extraordinary effort at national security and has developed programs and technology totally unknown to most of the community.
Yeah, but Richard, if that existed, NASA would have to be aware of it, wouldn't they?
Why?
Well, because they've taken pictures of it.
Some in NASA would have to be aware of it. Again, I come back to we're not dealing with a monolithic agency. The very fact that you had 2 representatives on your program that didn't know simple things that I know is evidence of the compartmentalization and the bureaucratization of an agency which is in its middle years.
All right, Richard, I just got a fax, and you got a copy of it, too, and I'm going to read it, and I want you to react to it. It's from Bob in Morgantown, West Virginia. It says, newsflash, STS-82 audio, what did they see? As I was watching live downlink from STS-82 at the end of the 5th EVA, the crew got back into the airlock, and the camera changed to Mission Control Center, MCC. Suddenly, the following broke through on the soundtrack. Crew voices. What was that flash? That light that flashed by me. There it is again. I thought I must be seeing things. What? I just thought it was my imagination. I saw it too, so it's not. There were two of them. There's another one. What are they? I just saw lights flashing in here. I wonder if they're, taking pictures. What is that? There. There's this thing. It just passed in front of us. What are the lights? Which ones? I missed, and then it misses something there for a second. But I had that one the whole time. Yeah, I had that one too. At this point, what may have been the comm controller left his desk on the left of the screen and moved to a colleague at the back of Mission Control to talk to him. The latter leaned forward toward the console as if to operate a switch, and the video cut out. Are you aware of that, Richard?
No, but it should be easy to track down. If this faxer recorded the mission elapsed time, we should be able to go to Houston, pull the tapes, and see exactly what happened,
all right,
as we've done with STS-80.
Exactly. It sounds exactly like the kind of object movement that you were discussing earlier.
Well, the first step is to verify the source.
Mm-hmm.
And so because we had a hoax before, remember the hoax Discovery audio?
You never know, of course.
Well, there was an example several years ago of a claim that astronauts were seeing something really extraordinary, and it turned out later it was a hoax. So you must be very cautious about air to ground, because you can have all kinds of things happening that is not real.
Sure.
But the first thing I would do would be to track down this tape from Houston, and this individual should try to do that, and if they have trouble, they should, email us or fax us, and we'll put our, sources on it, and we'll get a copy, but we've got to have a time.
But I can well imagine, Richard, that if the behavior of these objects that you're talking about in the video you have was observed by people, the conversation probably would go about like this, wouldn't it?
Well, then, of course, it's obvious from that. Let's just take the dialogue at face value.
Yeah.
It's obvious they didn't know what they were looking at.
Right.
Now, they come back to Houston. They are debriefed, and they say, we saw the damnedest thing.
Yeah.
And the guys that are debriefing them write this all down, and a few days later they say, did you ever find out what we saw? And the answer comes back, you don't want to know. End of discussion. Doesn't mean they know.
No.
It means they just have been told, and they're part of the military. They're told. You don't really want to know. There's a need to know. We have been living, boys and girls, in the national security state since 1947.
Well, I don't.
Didn't used to be that way.
I don't argue with that. I know we are, and I know they keep secrets they ought not keep.
This is my point. If we got the administrator, if Dan Golden would actually, want to come on and have an interesting, wide open discussion, the last thing I'm going to accuse him of is knowing things that he doesn't know, because there's no reason that he would know.
Well, what I'm trying to do, okay, that's a sort of an answer. What I'm trying to do is in fact to get you to say that, to get you to say, if he does come on, or Malin or whoever we can get, that we will keep the discussion to a good, hard science.
Remember,
discussion.
We had a very fruitful and worthwhile colloquy with Ed Mitchell.
That's true.
Right.
That's absolutely true, and I would expect the same thing. I mean, we've got plenty of good hard science here to talk about.
And Dan Golden is on record as saying that he wants to give Cydonia a good college try. That's a wonderful place to build bridges.
Yeah, but
Let's take him at his word.
Yeah, but his good college try is, admittedly, in his own words, because of not scientific interest, but public interest.
Well, yes, it does. Once NASA sets down a goal.
Yes, it does matter.
No, it doesn't. It really doesn't. Because in order to make it happen, for whatever reason, the same resources have to be brought to bear to make it happen.
Doctor, does it matter?
Well, sorry, I was mentally following up on an earlier point in the discussion, so I wasn't.
All right.
What was the premise?
Right, the premise is Dan Golden has said that, yes, we're going to try to image Cydonia, and we're going to do that because of so much public interest. In other words, he's saying because the public is putting on a lot of pressure because they want to know about the face on Mars. He's saying we're moving toward thinking about imaging Cydonia because of public pressure. And I said, no, we should be moving toward imaging Cydonia because of the scientific compelling reasons to do so.
Yes.
And that should be the argument.
Yes.
And Richard said, that doesn't matter. And I said, Doctor, does it matter?
Yes, I'd say it matters. I mean, we really ought to be doing these things because there is real merit in the science to be achieved here, and because we're a curious species, we really want to know.
But that's more a philosophical perspective. If the bottom line is you're going to point the camera in the right direction and clear the memory for enough time to get a decent set of shots, it doesn't really matter why they're doing it. It matters that we get to see it live and we get a chance to independently analyze it in addition to Malin's analysis and interpretation, and we get to all publish what we think is on that data when it comes out into public view.
I hear what you're saying, Richard. You're saying I don't care why they do it as long as they do it. But
what might make a difference is if Dan Golden thought there was a really interesting scientific question,
yes,
then politically he would put more heat on Malin to make the real good effort to make sure we got the data.
That's where I was trying to go. And so if we can, through a reasoned debate, get him to, in effect, say, yes, there is a compelling scientific reason to go to Cydonia more than anywhere else on Mars, then we get from A to B. Or he comes on here and he tells us why there is a compelling scientific reason to go somewhere else other than Cydonia.
When they lifted my press credentials for Pathfinder, I sent a 4 or 5 page letter to Dan Golden, which I think is on our website. And as part of my, problem with Laurie Boder's unilateral action, I raised the point, which is important to Dan Golden because he raised it at the Freedom Foundation, that he may not be aware, but the Cydonia hypothesis, the intelligence hypothesis, in fact, has gone through peer review. Mm-hmm. There are published papers, Carlotto's, Horace Crater's, McDaniel's voluminous academic independent review of all our efforts, which qualifies in the scientific protocols for peer review. Mm-hmm. And I said, if you are not aware of this, I am sure that Dr. McDaniel and others would be happy to make their work available for you to examine. I never got a response. Now, I don't know whether it's because I'm me. I mean, NASA politically does not exactly like me a lot.
Yeah, well, that's part of it, probably.
Or is it because he's too busy, or because he is merely tipping his hat politically and doesn't really mean anything he said about following up on Cydonia, or none of the above? It would be very worthwhile under this administration, which has definitely done more for openness in politics than many other administrations. Mm-hmm. Look at the nuclear issue under Helen O'Leary.
Yes.
If Dan Golden were directed to come on your show with 15 million interested Americans who are taxpayers, who are part of that political constituency that wants to see these images taken, if he would be responsive just politically, then we could have a discussion about all the other reasons he may not be aware of, including fundamentally important scientific reasons for testing this hypothesis.
All right. Well, I think to that they might indeed be responsive, and you can depend on the fact that they are listening this morning, and so we would offer that level of debate if they are interested. And if they are not interested, then in my mind that tells a story as well. However, the fact that they came to us once indicates to me, particularly after this level of discussion, that they may come to us again. And I think it would be a worthy, reasoned debate to have in front of the American people, and they seem to want to do that. So let's cross our fingers, knock on wood, and send faxes.
There is a precedent on your show.
Yes, oh yes. Yes, there is. Richard, I think we're going to hold on to you for the last hour. Dr. Van Flandern, I think we're going to let you go to bed because I know you're starting to fade on us. But would you like to have any final
He's all
words?
Considering that other point. So tell us what you found out from that other point, Tom. America wants to know.
No, I was thinking about the, that would open a new issue. Just very briefly that the face on Mars, the scenario I just painted with it being on the equator, it also points to a possible purpose for building such a face because it would be visible from the parent planet as an object on the moon above in the sky. If we had that technology today, we'd probably build something like that on our moon too.
I asked them last night if we were living on Mars and had an object orbiting Earth, a spacecraft orbiting Earth at the same distance that one orbits Mars, and took photographs of Giza, would we be able to resolve sufficiently to understand that they were artificial objects at Giza? And they said no.
Yeah, it would, of course, depend on the resolution involved, but if you had the kind of resolution available on the Mars Global Surveyor, the answer is definitely yes, because Mars Global Surveyor at high resolution is able it will have 2,000 pixels on each image, and that implies that each pixel will be of the order of a meter.
So it would settle this great question, no question about it, about Cydonia. Dr. Van Flandern, I really want to thank you for being here this morning.
My pleasure.
And we will definitely do it again. Take care, sir.
Okay, good night.
All right. And when Richard Hoagland comes back, we're going to open up the lines, and he's going to attempt to answer some questions from the public. So that little announcement saying the phone lines are open finally is about to be true. But I thought what we just did with these gentlemen was very, very important. I suspect, I'm sure, NASA was listening. We'll see what comes of it. From the high desert, I'm Art Bell, and this is the CBC Radio Network.
Now, here again, Art Bell.
Once again, here I am. Top of the morning, everybody. Great to be here. In a moment, Richard C. Hoagland is back for this hour, and what I'm going to try to convince him to do is to take as many calls as possible. Fast questions, fast answers. It should be a lot of fun. We've had a very productive evening, I should say. I think this summarizes things very well as we go back to Richard. Dear Art, from Honolulu, let me add my voice to what I'm sure is already a huge chorus of faxes begging you to schedule Richard and Tom with somebody from NASA, preferably some scientists, or, as Richard suggested, Dan Golden. I recall the discussion between Richard and Dr. Mitchell, which presented such a stark and wonderful contrast to the discussions on TV talk shows. To hear two intelligent gentlemen engaging in debate without screaming at each other, to hear them exchanging views and concepts in a civilized fashion, was a delight and a true learning experience. If you can now bring these two, Tom and Richard, into debate with others who hold opposing views or different views, the possibilities are immense for serving the public interest in a very profound way. I will fax Dan Golden to request his appearance. Thank you so much, Art, for providing the forum for discussion for these truly important questions. And that's backed up with another fax. Art, please give Dan Golden's fax number one more time. Richard, are you there?
I am here.
Okay. Let us do that. Let us give Dan Golden's fax number one more time.
Okay, and we must emphasize this is in his office in Washington. It's not his personal home fax. It's
right.
a public fax machine.
Right.
202, area code 358
358
2810.
2810.
202-358-2810.
All right. What I would like to do this hour, if I can, Richard, is, we rarely get enough time to do telephone, so I'd like to do some fast questions and answers, if you can.
Let me clear up just a couple of points.
All right, and then let's do that.
All right. I've been calculating while we've been talking the Hubble resolution.
Right.
Because, as I said in our web discussion, the main thing that Hubble could offer to this whole debate would be resolution. Superb optical clarity.
Right.
After the fix, it can see extraordinarily small objects at great distances.
Right.
The numbers that Ray and Don were giving out last night are simply incorrect.
Okay.
At Hale-Bopp's closest approach, according to published data from the Space Telescope Institute itself, it could have seen something about 10 miles across. Now, that's with the wide field planetary camera.
Okay, that of course is somewhat academic since it has already passed the closest point.
Well, but if it used with the faint object camera, which has an array of prisms and filters and ways to cut down the light, it could see something a little over a mile across.
And that would have been sufficient, surely.
Well, it would have been 1/25th of the projected diameter of the big chunk presumed to be in the center.
Right.
Now, the spinning disk of dust and gas in the Van Flandern model, with the little guys orbiting around this nucleus, would be much bigger. We're talking something maybe 200 miles across.
I've got you.
In other words, Hubble could have in multiple wavelengths. And that's not including the new infrared camera they went up and just put on in February, which would allow us to penetrate the coma,
sure,
the scattering of light that the previous faxer on Halley was intrigued with, and to get down to the nitty-gritty. In other words, the bottom line is that Hubble was the one instrument that could have resolved several crucial scientific questions, and it was not, apparently, to our knowledge.
All right. Well, I have no argument for you there, and I think that would be a good subject for debate. On the first-time caller line, you're on the air with Richard C. Hoagland. Hi.
Okay. This is me, then?
Yes, that's you.
Okay,
where are you?
I'm calling from San Francisco. My name is Doc.
Yes, sir.
And, Mr. Hoagland, I just wanted to say to you that I'm familiar with the videotape that you have, and I've read your book, and I find it very intriguing and very interesting. I think, actually, are you familiar with Thomas Kuhn's Structure of Scientific Revolution?
Yes, of course, yes.
I think that in the long run, a lot of the information that you're talking about tonight will come out and be shown to be true, and I think that some of the resistances, well, how should I say, it's like what Kuhn talks about, new ideas being resisted. My question to you is, are you familiar with, there's a documentary videotape that I saw by Jack Kasher regarding the shuttle video?
Yes, I am.
The proofs that he ran through on there, are you familiar with those as well?
Yes, I am.
What's your opinion of those?
Well, I think they're quite valid, and in fairness, Dr. Van Flandern has not seen Kasher's analysis. Kasher is a physicist at the University of Nebraska, I believe, and what he actually did was go to Houston, to Johnson, to the Space Center, and get the muzzle velocity, if you can use that term,
sure,
of the gas coming out of the thrusters. And he has a very interesting analysis where he literally cross-correlates the speed of the objects, the force in newtons or pounds of the expected, wind from the thrusters. And the bottom line is these objects, even on STS-48, cannot be what NASA says they are.
All right, Richard, it would be very helpful if by the next time we have you on with Tom is up to speed on these videos, and I'm sure you can arrange that.
Oh, that's easy.
All right, good. Wildcard line, you're on the air with Richard C. Hoagland. Hi.
Hi, Art.
Where are you?
This is Kathy in Reno.
Yes, Kathy.
Mr. Hoagland, it's truly an honor to speak to you. I have a question, or suggestion, whatever.
Go ahead.
Even though it's an unproven method, has anybody thought of the utilization of Carillion photography in trying to locate the possible energy residue in the asteroid belt of the planet that met its demise?
Let me convert that question. Carillion photography is interesting. I wonder if it might have any application, Richard, toward looking toward the energy that you talk about. This energy that you speak of.
You mean the hyperdimensional physics?
Yes, sir.
Yeah. Well, all right. In standard Carillion photography, you take a test object and you put it on a plate, which is subjected to a high electric field, several million volts.
Right.
And the plate is in contact with a piece of photographic film, usually color film. And the aura, or a non-visible surrounding effect in space, when the field is applied, shows up on the photographic plate underneath.
Right.
And it's not light. It's something else. Now, there are those who dismiss this as merely a coronal discharge.
Right.
It's not that. When you do it with living things, like leaves, if you cut the leaf, slice it off like 2/3 from the top,
right,
the photograph of the Carillion effect will demonstrate the full leaf, even though it's actually no longer there.
So might there be an application?
The problem is, how do we get a chunk of this planet into a laboratory onto the electric field plate?
That's true.
You can't do it by remote sensing. Now, what you can do, and this is a very interesting, and this is a brilliantly interesting idea, you could take some of these meteorites that they're finding, like the guy that fell from Mars, so-called.
Yep.
And you could apply this analysis to the chunks that fall to Earth. And who knows what we might find. It's such an interesting idea. I will be thinking now, as I go to sleep this morning, about who I can call up to maybe start the process to get something like this done.
All right, I wanted to pass something on to you, by the way. A lady called the other night and said, guess what? My son or daughter, I can't recall which, just won a science award in school based on Richard Hoagland's experiment on growing grass on a turntable.
You're kidding!
No, I wouldn't.
Oh, I've got to see it. We got to put it on the web. We have to publish it.
All right. I hope that lady will send it. I just thought I would pass it on to you.
Please fax it or email it. Our email is enterprise@caro.com. Our fax number is 201-271-1703. And I would love to know the details and to publish this.
All right.
With photographs. We've got to have photographs.
East of the Rockies, you're on the air with Richard Hoagland. Hi. Hello?
Hello?
Yes, sir. You're on the air. Where are you?
This is Leonard from Mitchell, South Dakota.
Well, Leonard, it's been a while. What's up?
I wanted to ask Richard, what's become of Hale Bob?
What's become of Hale Bob?
Yeah, I saw it 2 or 3 weeks ago, and
now you're not seeing it.
All right. Now you're located where?
Mitchell, South Dakota.
Mitchell, South. All right. You're pretty far north. You're north of us. It will be low in the southwestern sky, and it's getting lower every night because it's on the opposite side of the sun now, and we're kind of looking catty-corner across our orbit. And on the 5th of May, which is what, Monday?
All right.
It will go down through the plane of the Earth's orbit around the sun, and it will be then below the so-called ecliptic. And we're looking like cutting the cord. We're looking catty-corner after sunset in the northern hemisphere. Now, in the southern hemisphere, it's rising higher and higher and higher after sunset, so they're getting a better and better view. But it's leaving the northern skies, so if you got to get up on a high hill and have a low, flat southwestern horizon. Now, if you're further south in the United States, or in Hawaii, hint, hint, you'll have a smashing view for a long time to come, even though you're at low latitude, 19.5. And if you're in Australia listening to Art, what are you doing up in the middle of the day?
All right, Richard, what about for me and for people here in the Southwest, say, when will be the end of reasonable viewing of Hale Bob?
You got another 2 or 3 weeks, but it is going fast.
All right.
If you're far enough south, you should really still have a good view, about 20 degrees above the horizon, southwest after sunset.
All right. West of the Rockies, you're on the air with Richard Hoagland. Hi.
Oh, hi, this is Roy. I'm in Nampa, Idaho.
Yes, sir.
It's great to talk to both of you. I feel like I won the lottery or something. I don't see how well, who is the Democrat? I got Charlie Liberal and the guy you call the Devil's Toe Jam. I don't see how they seem to get through it well. But what I wanted to say, and I'm sort of confused, I find really plausible your theory that there's a black technology that they have and they're using, and it's probably real cheap to use, and then they want to make money off of this other one, like just to keep themselves in the bucks. I also think it's plausible that these things are from outer space. I also think it could be plausible that these are spirits totally tricking us. I mean, any of these could be true. But you seem to
you seem to project two theories. One is that it's the humans doing it, and they want to keep it quiet so we don't know they have the technology. And the other one is that that it's really aliens, and maybe the aliens are telling us not to, they're contacting the government, but they don't want the people to know. Now, if it is just a black technology and we humans are doing it, why would they be so weirded out that we would even test for organic chemicals on Europa? And also, why would there be a conspiracy not to let us look at the core of a comet? How would that fit either of those theories?
All right.
Excellent questions. I don't think we have enough time this morning to answer them, but these are really good. These are the most important questions, all right? And to really do service to them would require several minutes. Let me try to give you a broad picture.
All right.
If our investigation is accurate, if we're looking at stuff out there, artificial things, artifacts, ruins, ancient cities, and all that, they were made by somebody. There's only two models if they're made by somebody.
Right.
It's either other guys or it's our guys.
Or it's us.
It's our ancestry or somebody who's just out there in the galaxy and who visited.
Eminently reasonable, yes.
Now, that's point number one. If it's our guys, and our guys here now in power know it, then the game is to keep us from knowing our own heritage. It would not be the first time in history that people in power control people under them by keeping their true heritage from them.
But is it the most likely?
No, but see, I'm not assigning probability. I'm just saying these are the options.
Well, I'm asking you to assign probability.
But I can't. I don't have enough information yet. We need more data. What we do know on the record is every time this space agency confronts a scenario where it might find life, it runs in the other direction. The pattern is now getting pretty interesting and pretty clear, and anybody can see it. The Europa thing is over the top.
Yeah.
That's telling us that somebody is afraid for some reason. Now, there would be an internal reason to be afraid. It would open the system to too much discussion about everything else they've been hiding.
Right.
So don't keep them down on the farm and don't let them know anything interesting. Or maybe there is an outside influence, meaning if it is humans that have left all this stuff in the solar system and they're here now, they're back, then they being in touch with our guys in power might have simply laid down the law and said, you're not going to let this out of the bag. And what happened is that overt policy from the exterior bumped up against the natural scientific bubbling enthusiasm within the system from the interior, and this sudden flip-flop is where it basically hit the fan.
All right.
I can't prove any of this. It's just an idea, and what I found in our investigation over 15 years is if we follow the most outrageous ideas, not screen them, not filter them, not say, oh, no, that can't happen.
Yes.
Eventually, you find out. Where you don't find out is when you say, oh, no, that can't possibly happen.
Right. Well, that's a very dangerous statement anyway. East of the Rockies, you're on the air with Richard C. Hoagland. Hi.
Yes, this is Mike in Lexington, Kentucky.
Hi, Mike.
Hello, Richard.
Hi there, Mike.
I just felt absolutely compelled to call today. I've been thinking about all this for a long time, and it's just become completely obvious to me that one of the biggest problems we've got is these lies that are being told by the government and by agencies. It's made everybody so suspicious. Nobody trusts anything anybody has to say anymore.
Yeah, that's true.
We don't believe anything that people say anymore.
Cynicism has descended.
Cynicism is rampant.
Yep.
If NASA is truly the people they say they are, they need to confront this head on, answer any questions that anybody has with the people that have the answers, and let us know what's going on so that we can trust them.
We have the beginning of that kind of dialogue possible right now. We really, really do. For the first time, NASA has moved. They contacted us. They came on the air. Now we're inviting them to a reasoned debate on scientific questions. And so there is a chance for us all to move back together again. All NASA has to do is grab it and say, okay, we'll try it.
These people seem to think that we're kind of crazy for even questioning what they do. In other words, we're the scientists. We know what we're doing. You people aren't smart enough to figure out what this is all about. you're not even worth the time to justify what we're doing.
Yeah, well, if they want to do it, they now have an opportunity. It's like a representative. When they go to Washington, they have the best of intentions, but when they get there, they get self-absorbed. They worry about only being reelected and perpetuating their own existence and all the rest of that. So we really do have a golden nugget of an opportunity here if NASA's listening and decides that they'll participate. All right, bottom of the hour. We'll be right back. My guest is Richard C. Hoagland. The subject, or subjects, very non-trivial indeed. Maybe we can return some confidence and eliminate some cynicism. What do you think? This is CBC.
This is the CBC Radio Network.
It is. Good morning, everybody. From my desert to your location, wherever that is.
We're going back to Richard Hoagland and your questions, but I felt that you should hear this. Art Jack Hortimer's PBS Star Hustler show of the Miami Space Museum informed viewers tonight that next Thursday night, May 8th, just after dark in the western sky, not only will Hale-Bopp and its million-mile tail be visible as it travels away from the sun, but the sliver of the new moon will also appear right below. It should be quite a sight. Jack said this has not been seen by human eyes since over 4,000 years ago. Think of it. The pharaohs were likely the last to marvel at this phenomenon. Interesting piece of data, Richard?
Yes, very, very. Well, see, for people who live in cities, this is really the first time in a long time, maybe in many people's lifetimes, that the cosmos has kind of invaded our living room.
True.
I mean, I could go out. I live in New York City or right across the river, and it's very bright. You can almost see nothing. I literally could take friends out in the middle of our street in front of the house and past the streetlights, point up and see Hale-Bopp when it was in the upper skies here in April,
yes,
without anything, just looking at it.
Try and imagine what it looked like where I am.
Yeah, I've been trying, all right?
Listen, from KABC Radio, I was just about to turn the radio off, go to bed, when I heard your guest, Richard, talking about the camera on the Mars mission will have 2,000 pixels. Did he really mean 2,000 or 2 million? My company works on 2 cameras now for NASA and JPL for IR astronomy. In one case, the camera has 2 detectors near IR and far IR, and both imaging arrays were 128 by 128, which equals 16,000 approximately. The latest camera I'm working on has 2 1024 by 1024 detector arrays. That translates to 2 million pixels. Is it possible NASA is using an imager with as few as 2,000?
Okay, it was Tom who actually mentioned the numbers, and this is not a camera like he's describing. This is not an array with an X and Y axis.
Yes.
This is a line of pixels. It's a line of detectors, and the cross motion, the other axis of the image, is created by the orbit motion of the spacecraft.
Okay.
It's what's called a push broom camera in the trade.
All right.
And that's why you can get 25-mile long pictures.
All right. First-time caller line, you're on the air with Richard Hoagland. Hi.
Hello.
Hello. Where are you?
My name's Joe. I'm from Portland, Oregon.
Hi, Joe.
I had a question for Richard about, I have a video that's called The Mystery of the Sphinx, and it,
produced by Bill Cody.
I'm really nervous. Anyway, it went on with one side of the Sphinx. If you duplicated one side and gave it a mirror image, it looked like a man. And on the other side, a mirror image gave the image of a cat. And then they compared that to the Sphinx being half cat, half man. I just wanted to know what your thoughts were on that.
Well, since it's our work, I have some interesting thoughts. That is the part of the Mystery of the Sphinx video where Bill and John West, whose work is actually profiled in that video, are using some of my UN presentation a few years ago, where I laid out in the Dag Hammarskjöld Auditorium this data we have then just acquired where if you enhance the right-hand side of the face on Mars, it looks very feline. It looks very lion-like. The left-hand side looks very hominid or ape-like or man-like. That symbology on Mars at Cydonia is the identical symbology, man-lion image, of the Sphinx here on Earth in Egypt. Even more impressive is there's a mathematical linkage between the sighting of the Cydonia complex of face and pyramids and the sighting of the terrestrial complex, face, Sphinx, and pyramids. And there are other connections. So the bottom line, which was in this video, is, look, there's a very important reason for rephotographing Cydonia, not the least of which is it might be pointing directly at some very important recent data points in our own history.
And it also accounts for why I like cats. Wildcard Line, you're on the air with Richard C. Hoagland. Hi.
Hi, this is Curtis from San Diego.
Hi, Curtis.
Oh, well, I would like to make a couple comments and then ask a question, if I could.
Well, Curtis, get to it.
All right. Well, I wanted to thank the senators, and hopefully this is only the tip of the iceberg in what they're going to accomplish in this country. Also, I listened to your guest last night, and frankly, they answered questions not as quite as bad as Janet Reno, but just about. They sort of were a little bit shallow, and their voices were nervouser than mine was at points. Also, they talked about a mapping or some kind of thing prior to 1965 that was made that's different than the mapping they use now last night. And I also want to know, darn it, this is on my mind and in my gut, and since we're having all of these revelations, you see television in the news today and yesterday, I think I'm in a dream, but darn it, does this have to do with the JFK assassination, and when are those damn things going to be unsealed?
All right, well, in 50 years, and the answer is always yes when the question is JFK. East of the Rockies, you're on there with Richard C. Hoagland. Hello.
Yes, hello, Mr. Hoagland. It's an honor and a privilege to talk to you again. My name is Bill. I'm calling from West Hartford, Connecticut. I spoke to you about 6 or 7 years ago.
My old stomping grounds.
Yes. I have your book, Monuments of Mars, in front of me. Between pages 198 and 199 are some fascinating pictures. I'm going to read you just 2 sentences and ask you a question that's on the bottom of the famous picture of frame 35A74. It has to do with the cliff next to the crater, and the crater also has a 5-sided tetrahedron, a 5-sided pyramid on the rim of the crater. Let me just
3-sided actually, but go ahead.
Okay. Frame 35A74, enlargement of the cliff on ejecta blanket of ancient Martian impact crater. Lack of damage or blast shadow around the cliff despite major impact event at close range suggests cliff is of later origin than crater. Now, my point is regarding the 5-sided image on, mass on the crater itself and the cliff. I think a chipmunk with an IQ of about 0.5, looking at that, if he were a chipmunk scientist, would say that I don't think could be caused by natural origin, natural effects. It has to be maybe artificially produced, man-made, or in other words, by an intelligence. So what I'm trying to say is, I'm a little nervous here. Excuse me. I wish you could ask Dan Golden. Don't you think that alone, looking at it from a natural scientist point of view, where you have this cliff, where you have pointed out the cliff mass the crater to the right of it, that is your hypothesis, it covers the crater from looking at it from the Martian surface, from the face, and also, in other words, so the cliff which came first, the crater or the cliff?
All right. In other words, would Dan Golden find that to be a compelling question scientifically, Richard?
And then detail, please.
Well, I'll tell you who found it to be a stunning anomaly that needed answers, and that was Jerry Soffin. Many years ago, after while I was writing Monuments and we were doing the research, David Webb, member of the President Reagan Space Commission, and Tom Rautenberg, who was at that time chair of the small group at the University of California in Berkeley that was looking into doing the second phase of the investigation, and I had occasion to meet with the Viking project scientist, Jerry Soffin, in a hotel room in downtown Washington. And among other things, I showed him exactly that relationship, all right? And he walked right up to the screen And he was so profoundly intrigued and realized this was incredibly interesting and anomalous, and then he turned around and he invited me to give an invited presentation at the 10th anniversary Viking dinner in 1986, which they were going to hold.
All right, so then this would be a compelling presentation to make to Mr. Gould.
You would think. On the merits, on the science.
On the merits, on the science, yes. West of the Rockies, you're on the air with Richard Hoagland. Hi.
Hi, this is Joseph from Honolulu.
Hi, Joseph.
Good evening, gentlemen. I have a question for Mr. Hoagland. Mr. Hoagland, as far as mission control, after, say, our spacecraft leaves the atmosphere, they track it just by data alone, correct?
Well, they use radio. There are large antennas for the deep space tracking located about 120-degree intervals around the world. In Australia, in southern United States, in the southwest, a few miles to the west of Art, in South Africa, in Spain. And as the Earth rotates, these big antennas, hundreds of feet across, can track a 25-watt signal literally to the edge of the solar system.
I see. Now, would it be feasible for such a craft or this data to be simulated via a computer?
Yes, absolutely. I mean, we live in a virtual reality world. In other words, if I'm honest controllers at NASA in mission control, and I'm reading the data on my consoles, I really don't know where that data is coming from.
Okay, which leads me to my next third question. Now, would it be possible for all the guys at Mission Control, all the civilian employees there monitoring their little monitors, at some point during the mission to be switched over to false data from a false origin, and the original data being
we understand, caller. We exactly.
Not only is that possible, but that's one of the things that I'm most concerned about. And when I was at the Cape covering Mars Surveyor, I happened to run into a computer programmer from JPL who got very interested in what we've been discussing, and we raised in a car traveling from one spot on the Cape for about an hour to another spot exactly those questions, and I asked him to start looking, for that kind of problem. And so far, that's all I can say, because I don't obviously want to reveal his identity. But it's very similar to what I call the mad programmer in Jurassic Park.
Right.
Remember the guy?
Oh, of course. Yes, I do. Yes.
Who plays Needham Norton on Seinfeld?
Right.
The guy with the glasses. Anyway, all you'd need is one guy bought, and they could do most interesting things to make all the honest folks think one thing when in fact something else is really going on.
Even
with
the
data.
controller, sure. West of the Rockies, you're on the air with Richard Hoagland. Hi.
Yeah, hey, Art.
Where are you, sir?
This is Ken out in Ventura County.
All right. Question?
And I have a comment for you, Art, and a question. What date, May, was the sliver of the moon and the...
let me see here.
Is it May 8th or May...
I believe it was the 8th.
Okay, let me put
I looked at the star chart tonight, and the 8th rings a bell, I think.
Yeah, here it is. May 8th. May 8th is correct, sir. All right, do you have a question?
No, I have a comment for you, though, Art.
Well, make that when we've got open lines, if you would, because we've got a guest right now. First-time caller line, you're on the air with Richard Hoagland. Hi.
Hello?
Hello.
Yes.
Where are you, sir?
From Denver, sir.
All right.
I have
one of my
question.
favorite places.
Pardon?
One of my favorite places.
Oh, also. I was going to ask you something a little bit more closer to home. My question is, have we satisfactorily checked out the moon as far as its density? Because if it doesn't spin, I always wondered about that, and you're the person to answer, something like that.
Actually, there's a very interesting answer that involves seismology, doesn't it, Richard?
Yeah, and the short answer is no, we have not. There are lots of interesting anomalies in the long term and the NASA record dealing with density and something called the moment of inertia of the moon. The moon is orbiting the Earth in a funny fashion. I wish we had Tom back here because he could affirm that the actual orbit plots of the moon are not following standard Newtonian calculations. And this has been a problem literally for the last 100 years, and not even NASA understands completely why the moon isn't following what it should, which is Newtonian laws of physics. That is a whole discussion in and of itself. Does it mean the moon is hollow? No. But it means that maybe the mass of the moon is distributed in a very different way than we currently think we understand.
Not equally.
No.
All right. A wild card line, you're on the air with Richard C. Hoagland. Hi.
Hello, Richard. This is Dave, and hello, Art, in Anchorage, Alaska.
Yes, sir.
I just want to say, and also ask Richard, but I just want to say, Richard, you know, for the average guy out there, you know, layman's terms, I've been listening to you for years, and I've read your stuff and watched your videos, and my hat's off to you. You know, you bring this out to the normal guy, and you make us, you know, I try to tell other people and just spread the word. You know, we need like a society, the Richard Hoagland Society. And well, I just think it's great. But what I'm wondering is, I remembered a couple years ago, you were talking about possibly sending up your own satellite to take your own photos, and I just wondered if you were, you know, into that project.
Richard, let me expand that question. I have talked to a number of people who are involved in private efforts to launch rockets, and then eventually low Earth orbit, and then beyond. How do you view the whole question of private efforts?
Well, I obviously applaud them. You know, the more diversification, the more democratization of space that we can, you know, get behind, the better. What is interesting is we've been talking about a private space effort in terms of private companies, you know, private launch efforts, et cetera, for decades, and nothing much ever really happened.
It's true.
Well, it raises red flags for me. And I have a lot of friends like Jerry Cornell who to this day keep swearing about private enterprise in space, and I keep saying, Jerry, it ain't happening. Why isn't it happening?
Yeah.
It's like there's a glass ceiling. It's like something is not permitting us to do the natural thing, which is to evolve off this planet, develop all different technologies for getting out there. Heinlein said when you're in orbit, you're halfway to anywhere. The fact is that the same people discussing the same neat ideas of private space exploration and development are sitting around the same coffee tables now as they used to do 20, 30 years ago, and nothing has really happened. Why not?
We'll let that one hang. East of the Rockies, you're on the air with Richard Hoagland. Hi.
Yes, sir. My wife and I are both amateur astronomers. And
where are you located?
Lexington, Kentucky.
All right.
And
good dark skies.
Well, sometimes. We had kind of like a strange occurrence 2 times. One was back in late March. We were looking at M42 in Orion.
And nebula in the Sword of Orion.
Correct. And we had 2 scopes out, and I was monkeying with one of them, and I told my wife we have a refractor and a Dobson neutronium, and I told her to go ahead and man the refractor. And she said that, as she was looking up, she said, there's a star that's pulsating and it's moving. And I said, no, that can't be. And I don't think there's a variable or anything like that. So I was looking at it, and sure enough, it would pulsate on and off, and it was about the size of a star, and it moved west to east. We tracked it for 20 minutes. Okay, then what was really strange was in early April, we were looking at Hale-Bopp. And again, we had both telescopes out, and my wife said, I see this star again, or whatever it was. And I got to looking myself because I thought, nah. And sure enough, it was trailing behind Hale-Bopp, maybe about not very far at all.
Uh-oh, here we go.
Well, all right, I'm just saying, could it be a variable star? Because I know some of them have a period of maybe just like a day or so, or even a couple hours. But it was so strange. I mean, and I was wondering if any other amateur astronomers out there.
Did it vary in brightness as you were watching?
Yes, it did.
Over what period of time?
Just a matter of maybe 20 or 30 seconds.
Oh, well, then it wasn't a variable star. I mean, variable stars can't vary on that short time scale.
I didn't think so.
Nothing that I know of that you could have seen with a small telescope.
Well, I was trying to rationalize anything,
Well, you can eliminate that. So then you go for the more interesting. Was it a satellite? Did it have motions consistent with an Earth-orbiting satellite?
No, because I've watched satellites go across.
Couldn't have been something in geosynchronous orbit?
Possibly. I thought about that.
All right. That would be my first bet, is that you're looking at something spinning, which is, glinting in sunlight from panels or something.
But it wasn't.
There's a lot of junk in the Clark orbit, in the so-called geosynchronous orbit. Satellites that are dead and gone, and of course are going to be there for millions of years.
Yeah, they're probably moving erratically.
Well, they won't be moving, but they could be tumbling.
Tumbling, yeah, that's what
Would it stay stationary in back of Hale-Bopp?
Well, it would only appear stationary for a few moments, but remember, they're moving at 6,000 miles an hour at 22,300.
Mm-hmm.
So against the star background, they'd be moving at about 4 degrees per minute.
I see.
I'm sorry, 15 degrees per hour, which is the rotation rate of the Earth.
Okay.
So think about that. I mean, that's my first inclination.
I got some really good views of Hale-Bopp. I've got a 16-inch Dob, and I put a broadband filter on it and checked it out. And boy, I tell you, I even got the waves off of it.
What do you think of the waves? Wait till you see the pictures I'm going to publish on the web about the waves and how they relate to Van Flandern's model.
All right.
Stunningly interesting data.
There have been some remarkable photographs. One of the best I've ever seen, Richard. I've got up on my website. It was somebody in Alaska who took a picture of Hale-Bopp with the northern lights
with the
just absolutely blazing away up there.
Well, look at the close-ups from Francois Collet at Pic du Midi on the JPL Hale-Bopp site.
Okay.
Stunning close-ups of the nucleus and what's around it.
Well, listen, we appeared...
Here's that music again. Is that telling us something?
It's telling us we've done it again. It was really a fly-by night, no question about it.
Yep.
All right, look, we've got to get together again one night and devote a night to just, what we just did for the last hour, because it's a lot of fun, and you get a lot of information out that way, too.
Absolutely.
So we'll do that.
And let me make one thing. I want to thank everybody out there who takes the time and trouble to write or fact NASA and Ted Koppel and John Holloman.
And we've got lots of good reason to do it.
It is working.
Richard,
keep it up. It is working.
Tell them good night.
Good night, America.
That's it, everybody. Good night, Richard. And wherever you are from my high deserts, good night, America.